Everybody, I am delighted to be opening the platform engineering track here at State of Open. The first speaker in this track is someone who's very important. She's also your real track host, so you'll be meeting Liz throughout the afternoon, but it means that I have the privilege to introduce her for her own talk in this track. Liz is the Chief Open Source Officer. She's also an Open UK board member with me, so she has a real tight association with these communities and with this event. As I say, she's your genuine track host for the day. Liz's talk today is about eBPF, which, although it's not brand new, is a topic that I know that we've all been hearing a bit more about recently. It's a wonderful foundation for platform tooling, and I think seeing that growth and knowing those changes are coming is one reason why I'm so delighted to have Liz and this topic in our track today. So please give her a warm welcome.
Thanks, Lorna. Hi, everyone. I'm glad everybody basically gets like a table to themselves. But it's good to see some friendly faces. So, yeah, first of all, welcome to the platform engineering track here at State of OpenCon. As Lorna says, I'm going to be talking about eBPF. Can I get a quick show of hands? How many people here have heard of eBPF? Know anything about it? Pretty much everyone has heard of it. If you're like eBPF kernel engineers, we'll just take half an hour off and go and have a chat for half an hour. But what I'm going to do this afternoon is talk about why eBPF is such a great, powerful platform for tooling for infrastructure, things like observability, security, networking. eBPF gives us this really wonderful new platform for building the next generation of tools. So, the acronym stands for Extended Berkeley Packet Filter. Honestly, just forget that, because it does so much more than filtering packets today that the acronym has pretty much become meaningless. What eBPF allows us to do is program the way the kernel behaves. We can change the way the kernel behaves dynamically. So when I'm talking about the kernel, I should probably just quickly make sure we're all on the same page about the kernel and the difference between kernel and user space. As application developers, we're usually writing applications that run in user space. And whenever our application code wants to do anything that touches hardware at all, be that accessing a file, allocating memory, communicating with the outside world over a networking interface, starting and stopping processes, all of these things are handled by the kernel. The application can't really do anything by itself without asking for assistance from the kernel. Now, eBPF programs get attached to events in the kernel, and that means whenever anything interesting happens, be that triggered by one of our user space applications, or perhaps a network packet arriving at a particular point in the networking stack, we can have eBPF programs attached to all these different types of events and use that to either observe the event or maybe change the way the kernel behaves at that point in time. And because it's in the kernel is involved in all of the interesting things that our applications are doing. So it's an ideal observation point. It's an ideal place to have a perspective on what's happening across an entire machine. So I always like to show some code. Let's have a quick look at eBPF Hello World. So I've got in the top terminal window here, I'm just going to be printing out some tracing as it's generated. And I'm going to start by showing you my very simple program here. This is using a Python framework to write eBPF code in. This bit here, hello, is my actual eBPF program that I'm going to load into the kernel. I'm going to change that to say, hello, state of open. And then this part here is compiling and loading the program into the kernel, and it's going to attach it to a system call called execve. Execve is used to start when we start running a new program, when we execute a binary, it's execve is the system call that we use to do that. So anytime a new executable is going to run on my system, it's going to trigger my hello state of open eBPF program. So hopefully I've saved that and I can just run that. Let's bring up the tracing window as well. Okay, so nothing happens initially, but if in a different window I do something, anything, we see tracing happen. And whatever I run, it's going to generate that line of trace. Now, amongst the things that I've got here, I've got process ID information. You can see here if I ran PS, it told me its ID was 15863. That's part of the contextual information that I've got from that the kernel has generated with this line of trace. And the reason why I'm pointing that out is because my BPF program, from its vantage point in the kernel, can find out all sorts of information about the context of the thing that triggered it. So in this case, things like the process ID, or I could find out what user ID I'd run it under, what the binary name was. In fact, I could get hold of all sorts of information from the kernel related to the context of that event. As we'll see later, if the event was triggered by a network packet, I can look at and potentially even change the network packet. So contextual information is really important for eBPF. So eBPF comes with, or eBPF applications typically consist of two parts. They're going to have the bit of code that runs in the kernel itself, and usually some kind of user space code that's going to manipulate that, interact with it, maybe rather than just show boring trace messages, turn it into pretty pictures and make it real proper, powerful tooling. And we've been able to dynamically change the way the kernel behaved. So I didn't have to recompile my kernel, I didn't have to load a kernel module, I just ran a program and it inserted my eBPF code into the kernel. And that is a huge change. Before eBPF, if you wanted to change the way the kernel behaved, you had a couple of options. One of them is to write a kernel module, or the other is to try to get your change upstreamed into the kernel itself. If you manage to get some code into the kernel, well, great. It's going to be usable by everybody. Everybody will eventually have that upstream kernel in their distribution, but it can take literally years. Probably takes quite a long time just to get your change accepted by the kernel community, to get everybody to say, yes, this is a really good thing for everybody. But even after your change gets committed into the kernel, it literally takes years before that distribution, that release of the kernel makes it into the distributions that people are running in production. It's kind of part of the hardening cycle of the kernel. We just don't run really, really brand new kernels unless we have a particularly good reason to do so. In contrast with eBPF, well, you can just write a program and run it, change the way your kernel behaves dynamically and basically instantly. And you can also have custom changes. Just because I want my kernel to behave in a particular way doesn't mean to say that you all have to accept the same change. So we can have customized behaviors if we so choose. The other thing that's really important here is you don't have to reboot your machine. You can just load these programs into the kernel and, hey presto, the change is there. And this has been used for lots of really, I think, really cool examples. One I want to talk about briefly now is mitigating packet of death vulnerabilities. So this is a class of vulnerability where there's a bug in the kernel. That means if a particularly crafted network packet arrives it crashes the kernel. Maybe something like a length field in a network packet is set, deliberately set to kind of mislead the kernel, and the kernel doesn't know how to handle that badly formed length packet, and memory overrun or crash or whatever. These kind of vulnerabilities don't happen very often, but they have happened, a few times. And with eBPF, you can mitigate them immediately. So before the kernel gets to the vulnerability, before the network packet reaches the point where that vulnerability is in the stack, we can insert an eBPF program to look at each network packet, see whether it is this badly formed packet of death, and if it is, just discard that packet, drop it on the floor. The vulnerability never gets hit, and you can roll out that eBPF program to your fleet of however many thousands of machines you're running, just dynamically loading a program. You didn't have to reboot the machines, you don't have to reinstall them. If you're managing a large fleet of machines, this is a much, much better approach than having to wait for a kernel patch and reboot all your machines instantly. So the kind of code that would implement that would look something like this. It would be attached to a network event. It would do something to parse the packet. I've got an example here that's going to say, let's just drop ICMP, which is a ping packet. And if we drop a network packet, it just doesn't get through. That's fine. Does anybody want to see an example of that? Yeah? Good. Always good to have some live examples, right? So I've got a little BPF program here, this one, XDP, and it's doing some parsing of the network packet to see whether or not it is a ping request. And at the moment, it's just going to trace out the fact that it is a ping request. So hopefully, if I run, I think I called it SOOC. Okay, let's bring up the trace. And I need to kill the old program. And if I just start pinging, I've attached it to the local loopback interface. So I just ping myself, and we start seeing the tracing for those ping requests being received at the, on the same machine, but the other side of the loopback interface. Okay, so I'm going to leave that running, but I'm going to change this program. I'm going to drop that packet, and just to make it clearer, I'm going to change the trace so that we can see that the packet's been dropped. And if I run this program again, it's going to insert the new version of the program. Bring up the trace again. And what we should still see the tracing because we're still hitting that program, but we should see the ping requests stopping. So keep an eye on the sequence numbers. Okay. And now we're starting to see dropped appearing in the trace. And this bottom left-hand window, the sequence numbers have stopped incrementing. So I just changed the way the networking stack is behaving on that kernel. I think that's pretty cool, right? Okay. I mentioned before that the other approach that you could have would be to write a kernel module, and I kind of glossed over why you wouldn't necessarily want to do that. Writing a kernel module is the same as writing kernel code, and if you have a crash in the kernel, it's a bad day at the office. That's going to bring down whatever's running on that machine. That's no question. With eBPF, we have this process called verification that checks that your eBPF program cannot crash the machine. So it analyzes every possible path through your eBPF program. This happens dynamically as you're loading the program into the kernel. And it ensures that all memory accesses are safe. Every memory access is as expected, so that you can't be kind of reading into other unexpected, you can't use an eBPF program to, well, you can use eBPF programs for malicious purposes, but we limit what memory you can access, for example, from an eBPF program. And this verification process is what one of the things that differentiates eBPF from just writing a kernel module. Your kernel module, unless you've tested that very, very, very carefully, there is a chance it's going to crash the machine. That's one reason why a lot of end users are reluctant to use kernel modules. eBPF, that risk has been taken away because we know the eBPF program cannot crash the machine. So, how many people here are involved at all in cloud-native Kubernetes, that kind of world? Yes, quite a lot of you, most of you. Me too, I'm very into cloud-native. So, eBPF is an incredible platform when we're using containers, because however many containers we're running on a given bare metal machine or virtual machine, there is only one kernel. All of your containers on a given VM are sharing the same kernel. That's a common misconception that people sometimes believe that containers have their own kernel. They don't. They're all using the host's kernel. So however many processes are running, however many applications are running, however many containers in however many pods, all of those applications on a given node in Kubernetes are all sharing the same kernel. And every time those applications want to do anything interesting, like networking or allocating memory or accessing files or starting a new process, that shared kernel is going to be involved. So the kernel is not just aware of, involved in everything that's happening on that node. And if we instrument the node with eBPF programs, they can be aware of everything that's happening, regardless of what container they're in. So this brings to a contrast between eBPF instrumentation and sidecar-based instrumentation. So let's briefly review what I mean by a sidecar. If you have something like tracing or logging or security tooling that you want to add into all of your application code, well, back in the day, you'd have to implement, let's say, your tracing or your logging as part of your application. And maybe you would think, well, I've written this code a few times, so perhaps I should pull it into a library so that all of the team who are writing in the same language can use that same library. But a library is only good for the language that you're writing in. So you might have a team that are using Python and another team that are using Rust and another team that's using Node. They're all going to have their own implementations of these common tooling features like tracing or logging or security. So containerization allowed us to move away from that model and pull the common code into sidecar containers that can be implemented in a different language because they're isolated from your application by being in a container. So we can have our common tracing or security or logging, whatever tooling, written in a completely different language and attached to or used with all of our applications. So that's great. That's a real step forward, certainly in terms of being able to have the same instrumentation in all of our applications. But I love this cartoon that Nathan Leclerc did. This is quite a long time ago now. I feel like I've been using this cartoon probably for 3 or 4 years. I think it really speaks to how eBPF running in the kernel reduces or removes the need for sidecars. So let's just dig into that a bit more. So when we inject that sidecar container into a pod, we have to run it inside the pod because pods are deliberately isolated from each other. If you want your tracing or whatever to be able to see into your application, it has to share some namespaces with that application containers, and it does that by being part of the same pod. And to get there, there has to be some YAML configuration to make that happen. Whenever you're defining a pod, the pod's got a specification in YAML that says what code you want to run inside that pod. And you're going to have to somehow get the sidecar included in the definition of every pod. Now, normally that's done automatically in some kind of automated fashion. So maybe it's done as part of your CI/CD pipeline, maybe it's done through an admission controller, but something somewhere is going to take your application YAML and add in the fact that you want to have these tracing or logging or security or whatever sidecar added into every app. So that's okay, but if something goes wrong, or maybe some misconfiguration in your admission controller, your CI/CD pipeline, well, then the sidecar just doesn't get injected. There's no way to instrument something without getting the sidecar into each pod. In contrast, if we're using eBPF, we just have to instrument the node that one time. We have to load our eBPF programs into the node, and all of our pods are visible to that. All of our application code is visible to that. And not only is our application code that we're expecting to run visible, but if anything malicious starts happening on that node, eBPF can see it as well. It's still just a process from the perspective of the kernel. It's just something else that it can observe and react to. So I'm pretty sure that if I'm an attacker and I compromise your node, I'm not going to do you the courtesy of injecting your sidecars into my malicious application. So this is a huge benefit that eBPF tooling can see across all of our applications on each node, and we didn't have to make any changes at all to the app or its configuration. It's instantly visible. This model is also really efficient from a resource usage perspective, or can be. One of the other implications of using a sidecar is you've got a sidecar injected into every single pod. So suppose it's got some configuration information. That information has to be held. Well, it either has to be held in each pod, so you've got a duplicate copy in every single pod, or you're going to have to come up with some mechanism to share it, because all these pods are deliberately isolated from each other. So maybe you're going to have like network communications or files or something. It all seems very complicated, much easier to have copies of configuration information in each individual pod, which can come with resource bloat. Particularly in the world of service mesh, we've seen pretty significant amounts of resources used by sidecars. In the world of eBPF, we probably still need to have some configuration information in user space. We probably still have a user space application that we're going to use to interact with humans operating the system. But they only need that configuration information once if we've got one instance of the tooling in the kernel. There's also a concept called eBPF maps, which are data structures that we can share between eBPF programs in the kernel and user space. So we have this really efficient mechanism for sharing information between the kernel and user space that just doesn't exist between different sidecars running in different pods in user space. So it's a much more efficient way of sharing that kind of configuration information and a more efficient use of resources. So eBPF provides this incredible platform for tooling, this very resource effective, efficient, and kind of all-seeing platform for cloud-native tooling. There are a few really great projects in the CNCF that I wanted to mention. I say the CNCF because I'm quite involved in the CNCF. There are other eBPF projects outside of this world as well. Cilium, if you want to learn more about Cilium, lots of folks from Isovalent here who will be happy to talk about that. And an observability component called Hubble. There's another, I think I've got a screenshot in a moment, another really powerful observability tool called Pixie, which is the CNCF project. Tetragon, which is a security component of Cilium, and Falco, which is another eBPF-based security tool as well. Because they're running in the kernel, these observability tools can get really deep observability. It's very efficient, and we can pull together some really coherent information. So, for example, these are a couple of screenshots from Cilium's Hubble tool. We can get metrics showing network latency. We can build up service maps showing how services are communicating with each other. We can see individual network packets, or we can zoom out and get that much bigger picture of what's happening across the whole cluster. This is Pixie that I mentioned. This is an example of a flame graph showing CPU usage aggregated from across the entire cluster. It's pretty cool. And I've said the words high performance. I'm pretty sure I've mentioned those words. This is very efficient because if you're running in the kernel and collecting event metrics, there's no need to kind of keep transitioning between user space and kernel every time you collect a piece of data. Those user space kernel transitions are typically quite expensive. And we can see the results. This is an example of essentially parsing packets. Either, well, the blue graph that's the most efficient is not parsing them at all. The red one, which is nearly as efficient, is parsing those packets in the kernel using eBPF. And the quite a lot slower version in the yellow bar is what happens if you pass those packets to user space to parse and get insight into those packets. Just one example of efficiency from eBPF. I also want to talk very briefly about using eBPF to bypass parts of the networking stack. So this slightly scary diagram is approximately what's happening in networking when we're using Kubernetes. Typically, your application pods each have their own networking namespace, and that is connected to the host networking namespace through a virtual Ethernet connection. So that means that a packet coming from outside the machine comes in through a physical Ethernet connection, goes all the way through the networking stack on the host, then through the virtual Ethernet connection into the pod, where it goes through another traversal of essentially the same networking stack, just in a different namespace. And running a packet through, the more code it runs through, the longer it's going to take. So if we can make that network path shorter, it will make the networking faster. And one of the things that we're able to do with eBPF and the way that Cilium behaves is essentially to bypass the vast majority of the host namespace networking stack. So we can take that packet as it arrives on the physical interface and pretty much immediately send it into the pod. And again, that has, genuine performance impact. This graph shows a couple of different implementations based on eBPF. So Cilium, this is actually a few releases old now, but I think the point still stands. So both Cilium and Calico, which are both networking implementations for Kubernetes, you can see that eBPF implementations, which are the kind of two middle lower bars, are significantly, sorry, the other way around. The blue line, the highest line, is what happens if you've got no container networking at all. The eBPF ones are close to that, so the red and orange bars, which are the eBPF implementations, because we've been able to avoid the vast majority of that host networking stack, we can achieve nearly as fast networking between containers as we could node to node. And then, so I've talked about observability, I've talked about networking. Security is another aspect that eBPF can be used really powerfully for. Because we can hook into all these different events in the kernel, this is just a sort of illustration of all the different kinds of interesting events that Tetragon hooks into that we can then secure against. So whether you're talking about accessing sensitive files or wanting to keep an eye on which binaries are being executed, whether you want to see privilege escalations, all of these things can be hooked into in the kernel and then used to either generate logs, generate alerts. We can even do in-band killing of processes so that if the kernel detects a out of policy behavior, it can kill the process responsible directly from within the kernel. So there's no opportunity for that malicious behavior to actually take effect. Very powerful. So I've talked quite a lot about making the kernel programmable. I've mentioned Linux. Primarily, I am talking about Linux, and I am vaguely aware that there are other operating systems out there that aren't Linux. And in fact, eBPF is not just for Linux anymore. Windows now also has an eBPF implementation. This is now sufficiently advanced that there are proof of concepts of Cilium running on Windows, the Cilium eBPF code running on Windows. It kind of blows my mind that Windows and Linux that are so different can have, in some circumstances, the exact same eBPF bytecode running in both operating systems. So if that also blows your mind, come and ask me about that later. With that, I think I've got probably a few minutes if there are some questions. I hope there are questions, because I love having questions. And also, I'm just going to mention that later on this afternoon, we've got lots of copies of a little book that I wrote that explains in a bit more detail what eBPF is. So if you'd like a copy of that book, come along to the book signing this afternoon. I hope that's given you an introduction to eBPF. Thank you. I'm hoping there's going to be some questions. I see one there. We've got some mics coming around, I think.
So does eBPF always require root privilege to run?
That is a really great question. So I'm going to divide that into a couple of parts. So first of all, effectively, if you're running an eBPF program, it's in the kernel, it might as well be, you might as well consider it to be a root privilege, the fact that you can run custom code. Now, I've only shown you running it as root. You do need some capabilities. So just in case anybody doesn't know, Linux has a variety of different privileges called capabilities. And the exact set of capabilities you need depends a little bit on what kind of event you're hooking into. So you need different privileges for network events or for other kinds of events. But there is also this concept of unprivileged eBPF. And I think I'm going to make a wild generalized statement that I think most people in the kind of eBPF world probably think that unprivileged eBPF was a bit of a mistake. You can turn it off at the kernel level. So it's a kernel configuration to just remove the ability to do unprivileged eBPF. I would do that if I were operating a cluster or operating production machines. Yeah, so I hope that answered the question. I think more broadly as well, it's important to treat eBPF programs just as you would any other kind of root privilege program. They are inherently very powerful, and you don't want any random user being able to change the behavior of your kernel. It looks like you've got a follow-up question. And there's also a question at the back as well, so maybe we can cover both mics.
Thank you. Nice talk. I was wondering if you can compare the API promises between kernel modules, for example, kernel APIs and eBPF. Do you get any additional guarantee? Do you get more stability? Is there any guarantee at the moment? Okay, right. So I think you're talking about the kind of the sort of ABI agreement. Yeah, when you're developing eBPF programs. So system call interface
is probably the biggest surface of sort of guaranteed stability in the kernel. So you know that if you've got a user application that runs on Linux today, it will run on Linux in, you know, however many versions in the future, because that system call interface is sort of guaranteed to be stable. People add new features to it, but the sort of existing interface will always be maintained. There are a few other points in the kernel where that's also true. So there's, for example, Linux security module interface. Again, that's a stable interface. Everything else in the kernel is, at least in theory, up for change. It could change at any point between one release and the next. The reality of what changes is not quite so, you know, not quite so dynamic as that. There's vast swathes of the kernel that don't change from one release, you know, haven't changed in years and probably won't change. And that's one of the interesting things about the Tetragon implementation, because it's hooking into some points in the kernel that are expected to be stable. It's not guaranteed, but because the people who work on it also work in the kernel, they're pretty confident and, you know, see no likelihood of those hooks changing. So it is something that eBPF programmers have to be aware of. The other interesting thing is the data structures that you might look at from within an eBPF program can change from one kernel release to another. There is a, I don't know what to call it. It's a thing called compile once, run everywhere, which, again, super clever, allows an eBPF program written on one kernel release to run on a machine running a different version of the kernel through this mechanism of basically documenting what all the field offsets are and all of the data structures that are being used, and then adjusting that at the point where the program's loaded in at runtime. Again, super clever. We can talk about that in detail afterwards if necessary. Should we try and do that one follow-up question, and then that's probably all we've got time for, isn't it?
So I'm going to be a bit sneaky here and try and get in 2 questions. So the follow-up question was, is it possible to use eBPF from a container? And if so, wouldn't that affect other containers on that host? And then the other one is there a limit to the complexity of your eBPF programs? Because you have the traditional problem of the halting problem.
Yeah.
Have you solved that?
Okay, yes. So first question, yes, you can run eBPF programs from containers, provided you have the right set of privileges. And yes, that would affect the whole node. So that's typically going to be how a cloud-native instrumentation, you know, it'll be deployed as a container. The agent will load the eBPF program, and from there it has visibility over everything. What was the second question?
Have you solved the whole?
Oh, yes, the complexity limit. So back in the day, I can't remember what version of kernel this was, there's what's called complexity limit of, and it used to be like 4,000 instructions. So when I talked about the verifier and the fact that it analyzes your program, essentially has it used to be 4,000 instructions that it could analyze before it would kind of go, well, I haven't hit the end yet, so I'm going to say this might not complete. That complexity limit is now 1 million instructions. There's also something called tail calls, which allows you to call from one BPF program to another, so you can decompose your functionality if you need to. So you will hear people saying, you know, eBPF is not Turing complete, and that is technically true, but we haven't yet sort of, you know, I challenge somebody to find something that is not possible to implement in eBPF, rather than like we just haven't done it yet. All right. So thank you very much. Thank you for being an attentive audience, and thank you very much for your questions. I'm going to now switch into track host mode and welcome our next speaker. I'm just going to quickly bring up my notes to make sure I get the title and everything right. So our next speaker is Abhi Bangsa, who is a principal engineer at Syntasso and going to be talking about how building a great internal platform starts with the API. So let's give a giant round of applause to Abby. I think we might need to talk for a moment while we sort out the...
All right. Hi, everyone. We're right on time. This is good. I'm really excited to be here today to share with you some of my experiences building platforms to support internal software development. When we're doing this, there's lots of tools I'll talk about and techniques that we use, but what I really want to focus on today is how building an API for that platform can make a really big difference in how you can evolve your internal platform. I know we're all here on a platform track at a technology conference, so we're probably kind of on the same page on what platforms are, why we have them, why we use them. But I'm going to spend a couple minutes just solidifying that, making sure we're actually talking about the same thing and you see where I'm coming from this. So internal platforms have become all the rage. And it comes from the idea that we're all here to build software that supports the end user having a better experience. Doing more with less, and that's true from a sustainability point of view, from a user experience point of view, and otherwise. But as software developers, as application developers, we have a lot on our mind when we're trying to produce this software. We have to worry about security concerns, support, cost, and everything else. And there's a lot of complexity to delivering value to our end users. And that's all, you have to worry about that no matter what application you're writing. And so we started with this idea of trying to reduce that complexity on application engineers with that idea of the dev and ops model. That idea that some people can focus on the end user's application and some people can focus on operating that, handling that in production and at scale. For those of us that have worked in this world, we know that it has its benefits, but it really challenges us on the ability to deliver quickly. We get stuck in that world where you're waiting for someone else to do something, you have different priorities. App devs want to move fast, ops engineers want to be safe. Those can feel quite conflicting, even when both are just trying to help the end user in the end. So we introduced an idea of the DevOps model. This is where now all of a sudden you have everybody's skills in one team. That team now has the same focus about delivering value and making sure it can also scale and be valuable to the end users, all in one team. And this has been fantastic. We've sped up tremendously. We've given autonomy to our teams, but it's also had its challenges. When you get to a certain scale and a certain number of teams that are operating in this DevOps model at an organization, you get a lot of duplication of effort. So that goal of trying to provide value to end users, all of a sudden, large percentages of our time are focused instead on non-differentiating things like infrastructure, scaling, security. Non-differentiating, not unimportant. And so we want to talk about what comes next. And there we are in the platform model. Just to be clear, I don't think this is a silver bullet. I don't think this is going to be that in 5-10 years' time, we're not going to end up with another model coming that's going to improve on this. We will. But it's trying to learn from the lessons of our past and improve on that. So in this model, we have a set of DevOps teams, all handling the creation and the operation of their software, but acknowledging that some of that software is internally facing. So you have a team that produces and operationalizes tools to help other teams produce and operationalize their software applications to their end users. Those internal-facing teams are often called platform teams, and they can handle a lot of that non-differentiating but important pieces of operational code. So as a platform team member, if you've ever been there, or if you work alongside some of them, there's a lot you have to try and optimize for, and you have to balance. You want to think about things like, how custom does your business really need to be? Can you just buy a platform and bring it in and use it? Or do you have certain special things, special sauce to your business that you need to include? You also want to think about how easy it is to extend that to new capabilities. Are you an organization that is bringing in new technologies and new opportunities internally, and you need to introduce new capabilities all the time? Or are you quite stable? You need to think about the idea that the application developers, your users, may need things quickly. So we talk about in that old dev and ops model that things were slow. It might take weeks or months to get a new server because it involves ordering power cords. We moved into DevOps world, we moved into cloud, those things sped up. People's expectations are to have things quickly today. Can you optimize for a fast delivery of a new resource to teams? And you need to think about where that line is between your platform and your application teams. Where does the cognitive load, where does the understanding of how this runs need to sit? How far up the stack? So if you're on the platform team, you may, or use a platform at your organization, you may notice a few different patterns. I'd call this the pattern where the focus is on business customization. And you may see tools like a Jira or a Slack, Trello, anything where it's custom requests for an item that goes to the platform team and kind of goes into the magic box and comes out. And the magic box may have a lot of automation behind it. It may have code that is running, but it's very customized to the business, and people are waiting on a ticket system of some sort. So it does tend to be more slow, more manual, require prioritization, and challenges along those lines. But you get that business customization. You may want to optimize for things like new capabilities. This is where everyone just gets a key to the cloud. The cloud providers that we have, AWS, GCP, Azure, these are fantastic at covering the requirements of most application teams. They can give you databases and queuing systems. They can host your applications on containers or VMs. You are completely unblocked if you're handed keys to the cloud. They have an on-demand and self-service API you can use. But if you're in charge of governance or cost or compliance within your organization, becomes quite a nightmare to keep track of where everything is and try and lock that down later. So if you want to optimize for quick access to new resources, you may try to limit from being an API of the cloud to being an API of something like Kubernetes. It's a widely used, consistent API that can get people up and moving. But it's not really a platform. It's almost closer to infrastructure as a service. It's a very low-level API that requires a lot of deep learning to use effectively. So there's still challenges if you optimize there. If you've moved on from the idea of handing out keys to the cloud or Kubernetes, you may be looking at how to optimize your business processes, those higher-level needs of the business. Tools you might use in this space might be Terraform modules or Helm charts, things that you can kind of template out and hand out to people to use. This is great because you start to think about those business needs and you start to divide out who can create the infrastructure side of things and who is going to focus on the kind of using of those to produce end user value. But it was a template. So once it's running, who runs it? Is this now go back to the team who created the template when you have questions, or is it now yours because you're holding on to it? And once you start handing out templates, what's to stop people from changing them? And once people start changing them, rolling out improvements or bug fixes becomes a nightmare. So lots of positives, but also some challenges when you use this technique. And the thing is it's not uncommon to be in a world where technology is holding us hostage a bit and giving us a false dilemma. Technology is making it seem like it's one of these options. You can only have one of these benefits because each of these tools have their limitations. What we actually want is the best of all of these. We want customization to the business. We want on-demand and self-service. We want it to be widely accessible and easy to use, and to be kind of elevating the conversation from a database to a test environment or something that uses that database. So what I kind of implore people to do is to think past the technology, think past how to implement this idea, and think about the product that you're trying to produce. As an internal platform team, you are trying to produce an experience for your end users, for your application developers. And we, as users of technology around our lives, know that if we were asked by Gmail or email providers or our calendar providers or anything else to get used to it because that's what technology allows, we wouldn't be very happy. And the same goes internally. We want to produce experiences that our users, our application developers, actually see value in and enjoy using. So let's talk about what that platform is. I think one of the biggest misnomers here is that people talk about the platform as one thing. When this definition from Evan Botcher on a fantastic article, I've got a note of it later, talks about the fact that internal platforms cover a lot of pieces, actually. Yes, it's self-service APIs. Yes, it's technology tools. But it's also that access to services, knowledge, and support. And you need to be able to kind of package that all together into an experience for your internal users. And so when you start thinking about this like a product, you start thinking about the fact that this isn't just a project to figure out how to automate the creation of databases. This is a product that needs to be long-lived. It needs to be user-focused. It needs to actually be owned by someone who is thinking through a roadmap that takes time and energy to craft and to prioritize. That is how you end up with that experience. But I am not the pro on that. There are amazing other talks coming up today that I suggest that you check out if you're interested in this space. They're going to talk a lot more about why and what internal platforms work and how they work. I want to focus on how to get started. Because as a platform engineer myself, I have been on teams, and I can tell you I have never had a free moment to try and introduce this idea of a platform product. It always feels out of reach. And so introducing a way to get started, I think, would empower a lot of people to just start this journey and not feel like you have to succeed day one. So to get started, you have to think about what you want to prioritize and work on. One way that I've tried to do this is to use that idea of making work visible. And with this, the idea is that when requests come in, make sure that they're actually tracked. How frequently do they come in? How long does it take to gather all the requirements of that request and to deliver that request? Someone needs a new database? OK, that's a piece of work. It shouldn't slow down your process, just track it. This will help you understand what is the most frequent requests, what are the most difficult and inconsistent requests, and where is it that it's taking time away from your delivery of the platform. These ad hoc requests are extremely difficult to standardize. This is where we start to feel like we don't have the empowerment to improve our platform. Because there's some long lead times, because tickets run in from all different directions, they're hard to prioritize against each other. They tend to require a set of toil work that is defined by the Google SRE book, if you're interested further in that, but usually around ideas like it's manual, not value-driven, and it's hard to scale as the organization scales. And the most important thing I'm focusing on here is that these are really hard to evolve. How do you shift the behavior from people pinging you on the side, asking you for something that you need, to something where you're actually providing a service? That's what I want to focus on. Let's stop that negative cycle of people introducing things or asking for things in an ad hoc way and introduce an API instead. So what is an API? At the highest level, it's a contract. It's a codification of the expectations between someone who produces something and one or more people that are consuming it. The really powerful thing here is that it allows for a separation between how you deliver it and the person who's requesting. So as a consumer of an API, I know what I want. I don't have to care how you give it to me. We have now that separation, and we can empower each side to do what they need. When we apply that to being in a platform, it provides us the ability to have a discoverable catalog of offerings. We have a plethora of options for interfaces. There's no need for this to just be a CLI. It can be a user interface. It can be a chatbot. Once you have an API, you can call that from any user experience that makes sense for your users. often more than one, to be honest, depending on what your organization looks like. It allows for on-demand offerings without requiring everything to be automated or everything to be immediate. Think about when you buy an airplane ticket. When you do that, you're online, you put in your order, and they say, great, you'll receive an email shortly. And we all just go about our business, and we get our email in 10 minutes to a few hours away, sometimes days, depending on the website. And that's okay, because we know that we've sent in the confirmation, and we'll get that email in a minute. APIs don't have to be synchronous. They can allow that sort of manual intervention. So don't feel like you have to go all the way to automation. And that's how we allow that idea of a do-nothing script, if you've seen that before, where you provide that interface of a script that tells you what needs to be done. And as you automate things, that's fantastic, but you know what pieces have to be completed. And that's the idea of a do-nothing script. So platforms, the reason why it's hard to get started is because they can be daunting. They are a product. They are a product just like any other product you might do in e-commerce, travel, any other industry. You have to think about things at the user interface level, like what options do you want to provide, and are there going to be validations on those options? What are the kind of higher level offerings that might be called paved paths? You also have to think about all the business logic behind the scenes. What are you going to do about your security and your auditing? What are you going to do about FinOps and cost allocations? How are you going to handle your customer requirements that are individual and customized? How are you going to handle upgrades and deletes, onboarding, offboarding? And how are you going to do this on a pretty diverse set of technologies and set of infrastructure? You might have some code you can declaratively write. Others you have to make requests to APIs themselves. How do you mix all that together? Then, of course, there's actually sending it to that infrastructure. How do you keep track of what infrastructure is available to you, on-prem, in the cloud, in a cluster or not? How do you manage that infrastructure changing, evolving, and making sure that the requirements you have, the resources you need, get to where they need to be to run? I would advocate that you can start with an API-first mentality. With an API-first mentality, you don't have to worry about that business domain logic. You don't have to worry about how you send the resources out to your infrastructure. You already have processes for that. Worry about that contract you have with your users, how to get started with what are the fields that you care about from them, what validations do you require, how do you make sure that you have the right conversation with your users. Focus on that first, then you can make time and space with reduced ad hoc requests to improve the business process behind the scenes and automate. So I would advocate that a goal would be to create a simple API that has the maturity to handle complexities as they grow. You don't need to worry about all the complexities day one. Get started with starting that muscle memory of going to an API, going to a catalog of offerings by your users. And as we're here on an open source conference, I want to introduce Cradix, which is a free and open source framework for helping to package up that complexity of the platform domain. It is not a platform. You install Cradix and you don't all of a sudden have databases as a service. What you have is the ability to tackle those hard problems for your business of how to introduce that user interface, take care of all that business logic, and manage all of your infrastructure. We do that with the idea of a custom resource called promises. For those that have worked within Kubernetes, I know Liz confirmed many people are in that cloud native world and using Kubernetes. It's just a custom resource in Kubernetes world, which means that we can define pieces to it. So we define our own custom resource definition, which allows for that API that the users will interact with. We also define ways to implement business logic that's called worker cluster resources and pipelines. And there's logic for dynamic scheduling across your infrastructure. I'm not going to dive into all the details of these bits because, again, the whole point is how do we get started quickly? I'm just showing that there's the maturity there to handle complexity as you grow. So with the idea of this promise, we now have the ability to create a catalog of services. Each service you want to offer, for example, databases as a service, like Postgres here, or cache as a service like Redis, or app serving like Knative, can each be their own promise independently and independently requested by users. But there's also composability. So you can create yourself the easy button, the kind of package of an app delivery that allows for one team that wants to create a new application to be given all the tools they need to be successful: databases, caches, and app serving. The other piece of it is that those fields are not required. You can implement them when you need to and when they help you. So in the idea of introducing an API with minimal effort, we don't need to worry about the provisioning side of the promise. We can just fill in the concept of the X as a service CRD, which gives us all of the groundwork that Kubernetes gives us for free. So it gives us a way to define fields and validate those fields. It also gives us a way to handle versioning and upgrades of this API. We don't have to create that from scratch. We can build on the shoulders of giants. We also can use the X as a service pipeline that comes as a part of a promise. With this, it's just a set of OCI containers, or Docker containers if you're more familiar, that can run in a pod on Kubernetes. So anything you can do in a pod, in a container, you can do as a part of this pipeline, whether that be validating permissions, security scanning, making requests to third-party services on SaaS products. All of that can be done in this pod. So being a bit concrete, when you want to make that first API in Cradix, you can define a really early version number, which you have to do. It sets you up for success on evolving this API. And you can start to capture key early data that you know you need, knowing that you're set up to version this API and introduce new fields and change fields as you learn about your users. Then, on that request pipeline, you can take in the values from the user and just ship them to wherever you currently get your requests. Do you currently use Slack? Send yourself a Slack message to the team channel with all the details that the API requested. It doesn't change anything about your process. And you may wonder, well, why are we introducing a new tool if I don't get to improve anything? What it's doing is it's stopping that negative cycle of having ad hoc requests that come in with a variety of data that you're not sure if it's complete or not. And it sets up your team, your application developers, to have the muscle memory of using your APIs as an interface to their needs, forcing you to improve those interfaces to the point where they're happy to use them, but allowing you to implement behind the scenes however you'd like. So I'm going to jump into a demo now, which is going to showcase using a promise from the marketplace. So we've got a marketplace of available promises that can get started quickly. Specifically going to use the Slack promise, showcase how to use it by itself, and then how to evolve that ability to send a Slack message into an API that can help you get started as a platform team. So let's see. All right, so I have my magical assistant here that will type for me. What we're going to get started with, how's that for font size? Is that OK for everyone? Is that good? OK, cool. We have a kind cluster. This is a Kubernetes cluster running on my local computer. I've called it platform to indicate this is like a cluster that I'm, as a platform engineer, kind of controlling the software on. You can see that on that cluster, I have Cradix running, so that's a set of pods that are running, and that is what's going to manage this API for you when you define the pieces of the API. So I need to go ahead and get that promise from the marketplace, so I'm going to go get that Slack promise, and I'm going to save it into a folder called database, because I'm going to evolve it into a database promise eventually. With downloading that, and yes, that was SVN from GitHub, got a lot of crap for that before. With downloading that, we'll get into the directory, and you can see that we have a few pieces to this promise from the marketplace. Those are README we'll just look at in 1 second. There's an internal directory which has some tools for encouraging people to actually edit the promises and make them their own. It has some helper scripts that we'll use. But all you actually need to get started is that promise.yaml that can be installed immediately onto a cluster, and an example resource request, so that you can see what the experience would be like for your users, the application developers. So let's get started with the README, because we are going to be posting to a real Slack channel. Oh, shoot. Give me one sec. Take that out. Need to go get my password really quick. All right, plug back in. So we are going to be going to a real Slack, which includes needing a webhook URL, which is a private value. So I have just put in my password, which has created a secret, hopefully, in Kubernetes. It has. So I've now introduced a secret into my cluster, which is by the name Slack hook channel, which you can see in the README is required for this promise to work. So Kradix has a convention based on names of the secrets or names of the promises to be able to read secrets as needed. So I've introduced this secret, and I can now have a look at what this promise actually does. So having a look at the promise, we spoke about how there's lots of fields you can fill in, but the two that are most important to get started for our use case is this Exodus service CRD. You can see starts on line 8. And for those that have experience with Kubernetes, you'll notice this is just a Kubernetes CRD. So down in line 21, we introduce our first version. And we have a field called message, which is just of type string and is actually a required field. That is our contract with our users. It's pretty simple today. We can evolve that. We can change that, introduce new versions. We also have a pipeline defined. It's a list of container images, which in this case is only one image because all we're doing is an API call. So that's all we really need. With that kind of basically understood, we can go ahead and introduce that into Kradix. We can load that into the Kradix library. And Kradix can tell us what is on offer from the platform. So what promises exist? We have a Slack promise now. That Slack promise contained a CRD, so now I can go and get my CRDs, and now these are the what's on offer to our users. What can they make requests to? They can ask for a Slack. So how would they go about asking for that Slack? Well, it's an API request to Kubernetes. Now, your users very well may not want to make requests to Kubernetes. You may use ideas like GitOps and store this in Git. You may want to use a user interface, Backstage or otherwise. Those are all fine because this is just an API. You can use whatever interface your users would best work with. But for this demo, we're just going to use Kubernetes. But hello world's a bit boring. So let's open up this code base and actually say hello to everyone here. So hello, state of open. And use some custom emojis, whatever it is that we have in our Slack is fine. Now I can go ahead and I can apply that resource request. And that's been created. With that created, I can also get a list of what has been requested of this API. So I can go and get what Slacks people have requested. I can see that my example Slack was requested. This would be fantastic as a platform owner when there's things like vulnerabilities. Who's using the things in your organization? Here is a built-in list. You may not want to use kubectl as your interface, but all the data is there and can be loaded anywhere. So with that request, we also kicked off that pipeline that we had defined. So that's that pod that has run and completed. And if I jump into the web, I can see that at 2:11, yep, just now, we got a post to our demo channel with hello state of open. That is as simple as that promise. That's all it does. You might argue it's not a very powerful promise. Who wants to write their Slack messages via an API, via Kubernetes? Talk about a little bit of overpoweredness. But what we're going to do is use that mechanism to make it a lot more powerful, to provide our first API for databases on demand. So to do that, we have to do a few things. First of all, we need to go change everything in that promise from talking about Slacks to talking about databases. So go ahead over into promises, and I can select the word Slack, change it to database, and the one thing that still needs to be Slack is that secret we had created, that Slack channel hook. So that still needs to point at Slack, but everything else about this is now a database promise. Cool. We also need to change our fields. I don't want to just take in an ad hoc request. That's the whole point of this API. I don't want just a message. I want specific information. So I can come back up over here, and I can change this message to the fields that I think might be valuable to the users. These are just to get started. Sorry, got an extra message there. These are just to get started. You might want a database name, a provider, a size, but it gives you an idea that you can validate this information. Name and provider, those are strings, but size, I want an integer. I can take in any name you want, but when it comes to provider, we as a platform team only offer certain database providers. We only offer Mongo, Postgres, Neo, and Dynamo. Pretty good platform team, to be fair. It's pretty much all you need, but that is what you can request. And then I want to say which of those things are required. I, as a platform team, may choose to make all of them required, or I can choose to have sensible defaults. In this case, I'm making them all required. Once those are all filled in, I need to actually have that information make it to the Slack message. So now I can enter into that internal directory, that request pipeline. This is all just a nice way to kind of manage our promise here. And I can see that it's a really simple container. It's just a curl request using that secret. But we can see that the message is really just about taking the information directly from the request and plopping it into a Slack message. When actually what I want to do is I want to go and get those 3 pieces of information, and I want to craft the message to read with those pieces of information independently for me, so that I'm able to pick this up and do this work nice and easy with all my necessary data. With that done, I need to go in and change the default resource request to make sure it's going to actually request a database instead of a Slack. And given that these are all required fields now, I need to make sure that they contain, that the request I'm making actually manages those required fields. And with that, I can rebuild the Docker image. This is a script that's also in that internal directory. It just helps us out by allowing us to build the Docker image using the correct name by convention and load it into that local kind cluster. This allows for a fast local development, but also contains the ability to push that to a container registry when you are ready to release this to your organization. With that happened, I'm able to now load that promise into my Cradix, which gives me now a second offering of promises, which then in turn gives me a second API for my users to make requests to. So I can go ahead now and I can apply that new resource request. And those that are eagle-eyed among you might have thought I made a typo, despite all my copy-paste, because I requested a MySQL database. That was just to quickly show you how this API has validation built in that you can handle in whatever interface you choose to provide to your users. Here, it's telling me that MySQL is not allowed because I have Postgres, Mongo, Neo, and Dynamo. So as a user of this platform, I now have a decision to make. Do I go talk to my platform team about a capability that they do not offer me that I need? Do I go talk to them about why I need MySQL and why that platform needs to extend its offerings? Or do I look at this list of offerings and realize MySQL I don't need, I can just use Postgres, that's fine, and I can use it. It's always a conversation. The platform is about supporting your users and listening to what they need. In this case, I'm easygoing, so I can use Postgres. And so now with that change, I can reapply this resource request, and it will actually create that database request. That will give me a list of databases that have been requested, the one I just made. And I'll be able to see that a pipeline has run as it was declared for that promise. With that, I can return to the browser, and I can see that I now have a Slack message with all the details required to fulfill a request for a database. I have an API now that I can change. So again, pretty big heavyweight piece of technology to introduce if you're not going to change anything about the rest of your work as a platform team. So maybe a bit more fun would be to look at now, because we've introduced that API, how we can change the back end. Now, switching from a Slack post to a Jira post may not seem like a lot, but it would change us from having something that was untracked work to having tracked work. There is benefit there. And it just shows a little bit of how you can change the back end without changing the front-end API. So I need to create a new secret. Now that the password has been entered, everything happens behind the scenes. And I can see that I now have a Jira API auth secret in addition to that Slack channel hook. I need to now make sure that that secret is something that the pipeline can read. So I go back to the promise where I have that Slack channel hook, and I introduce the new secret. This is how the convention of being able to read secrets from your pipeline based on the name of the promise. From there, we need to change that pipeline now from posting to Slack to posting to Jira. But I'm actually not going to completely change the pipeline. What I'm going to do is I'm going to change the message and introduce a second post. So the first thing I'm going to do is go get that Jira key, which is going to allow me to make the post to Jira. And then I'm going to make a very pretty curl request to Jira using that key to my project and specifically filling in the custom fields that my team has set to make sure that I'm keeping track of the information in a consistent way and I can query it. And I'm going to still make that Slack message because what I'm going to do is send to my team a notification that a new request has come in. This can help my team know that they have to prioritize user work. And maybe in the future, when everything's automated, we don't need that Slack message. But for now, I don't have to have that delay of someone's posted something to Jira and then sends me 10 messages being like, did you see my Jira? This is going to make sure that that's saved. So with that, I need to build and load that pipeline image again. And while that's doing the build and load, I can update the resource request name because this is a Kubernetes resource, which means that I wouldn't be able to make something by the same name. So I'm just going to call this the Jira example. I can make some changes here as well. Like this is the Open UK one, and change the size, just to show that it's a bit different. With that, I can reapply that promise file, and you can see that we actually didn't change anything about the promise. That API has stayed the same. But what we've done is configured new credentials for this to be able to exercise that container. Now I can make a request for another database, which means that I now have 2 database requests in my system. And I can go and see that I have a second pipeline running, which is still currently running. And with that, I should be able to see that a new request has come into my Slack, but now it's a simple link out to Jira. And when I click on that, I load up Jira, and I've got all the information here that I just put in, Open UK, size 2 gigabytes, etc. So I've now been able to change the implementation behind my API without impacting the users at all. Of course, I will need to impact the users as I introduce new features, but that's what they'll be looking for. They'll be asking for the ability to make MySQL databases. They will be asking for the ability to configure other pieces, like maybe when maintenance is for their database. We can introduce those as fields as we understand the needs of our users, because we now have this API. So with that, just to kind of capture a few of the things that I think are really valuable here is that as an engineer of any type, let alone an internal engineer, I think you can feel the pains of toil. And it can feel impossible to move because you're just perpetually doing business as usual work, feeling like people are always asking you questions, always needing to do something. And you're not actually improving things. You're just kind of treading water. But there are ways to improve things. And it's OK for communication to start in a manual way. To start with that API, just sending a Jira ticket, just sending a Slack message. Actually, communication pretty much has to start manual if you actually want to listen to your users. So it's OK to start with that API first before you actually worry about automating anything behind the scenes. That API can give that clean communication boundary and give you that ability to iterate. So people talk about evolution over revolution. It gets used a lot by managers about why you don't have the time to do things new, get those new tools into your organization and things like that. It's OK, and it's actually preferable to look at evolution many times, because that's what you have the buy-in from your organization to do. But make sure you're using revolutionary tools that will grow with you and give you the space to grow that platform into what you actually want to offer. thank you so much. If you jump onto the Schedule, there are additional readings that you can find. I've uploaded the slide deck, and this has been fantastic. Do we have any time for questions? Yeah, I think we have a few minutes for questions, if anyone has any.
Thanks, Abby. Yeah, I have a question. Actually, I have two questions, and why not? So one is, I think you mentioned Backstage, and I'm kind of interested in where you see sort of Backstage interfacing to that kind of API. And the second question was, we saw the request. It's an asynchronous request to create a database. Do you foresee having a sort of equivalent response coming through that API in some fashion?
Yeah, both fantastic questions. So first of all, Backstage is a great tool. We're seeing a lot of chatter about it. I think when people start actually trying to implement Backstage, they realize they get into just the same challenges any application development gets into. How much logic should you have in your user interface? Backstage is a user interface. It's a fabulous one. It's pluggable. It has some things you can take from the community and build on, but it is a user interface. Do you want your platform logic in the user interface? You probably wouldn't do that for your web application. Should you be doing that for your platform? So where I see Cradix fitting in with that is perfectly. We actually have a demo on our blogs of how you can drive a Backstage user interface from a promise. So co-locate that user interface in Backstage using GitOps methods of storing in a repository and driving Backstage from that. Co-locate that with all the logic of how you actually implement that as a service, whether it be a post to Slack or whether it be something more automated. So yeah, I think that there's a lot of space for them to work together a lot. The other question was around, give me a trigger.
Asynchronous.
Oh, the asynchronous, yes. So yes, again, we're able to build off of the amazing framework that Kubernetes provides. So Kubernetes has the concept of statuses, where you can post back information, and that's just JSON. So we do have the ability to post statuses back, and so at the most basic level, it could be a pointer to like go here to learn more about or to go find the secret connection string for your database. It could also include like statuses of provisioning and re-update that when things are done. You can have a process within your platform team to say done provisioned. Yeah, so we use statuses to be able to communicate back. Anyone else?
Yeah, I had some questions,
yeah,
actually.
Please.
I also had two questions.
I just have to keep track of them.
So one was, how would you compare with, let's say, using Terraform modules, like curated Terraform modules you would offer to your consumers? I can see some similarities in some ways. And second question is how easy it is to add a promise to the marketplace. So you don't have to reinvent the wheel every time you want to.
Yeah, those are both great. So I mentioned Terraform, and I'm a big Terraform user myself. It's an extremely useful technology, but it's code, and code isn't an API in my experience. So I have been the platform engineer who's offered Terraform modules to software engineers before, and they look at HCL and they go, what? Or they go, ooh, new thing, and they go completely down a rabbit hole away from whatever it is they were meant to be working on and go learn all the ins and outs of Terraform. Both of those outcomes are not exactly what we're looking for from an organization point of view. So Cradix is nothing without the tools behind it. So without great operators, great Terraform modules, great Helm charts, all it is a front for it. So what I would imagine a situation being is you'd create a promise that then would call those Terraform modules as a part of the pipeline. So you can use tools that have operators in clusters that apply the Terraform, or you can call out to Terraform Cloud or to a tool like an Atlantis that can run your Terraform for you. However you currently run Terraform, your pipeline would run that, rather than someone needing to come in and copy paste the code and figure out how to use your module. And I once again forgot the second question.
The second one was about the marketplace.
Yes, marketplace. So everything about Cradix is Apache 2 license, so it's all open source. We'd love to have both feedback and contributions to the code itself as well as the marketplace. The marketplace is meant to be globally available, but we expect there to be a world where organizations use both the widely public options, as well as create their own internal marketplaces. As for adding it, it's as simple as a Git pull request. So yeah, you can go ahead and use the ones that are there. They're all pretty kind of easy to get started with, and likely will benefit from more kind of business-specific needs being built in as you get to using them. But they're as simple as the Slack one, just to get started and then extend. So, and the tools are all there. Cool. Thank you all.
Thanks so much, Abby. Wonderful. So I think it's time to welcome our next speaker to the stage. I'll just talk for a moment while you get your laptop plugged in. So our next speaker is David Charbonneau, who is the CTO at Mimoto. And his talk today is going to be about the why and how of platform engineering with open source. So I think that could be a very good follow-on from what we've just heard from Abby. So while we just get a little bit of connection sorted out. Is everybody having a good day today? Yes? I think we could do better than that. Do it again, come on. We're having a good day? Yes. All right, so are you set, David? There we go.
There we go.
Is that that's still the holding slide, isn't it? We'll be there momentarily. Unless if you're ready to go, I will.
I can wait a minute, I suppose. Nice to see everybody. And I just wanted to say, Abby, I thought that was a really wonderful presentation. I really enjoyed that. I hope you'll see echoes of some of the principles behind it in this one. Well, I guess I'll go ahead and get started.
Are we good to go? All right,
sure.
Wonderful. Big round of applause for David.
Hi, everyone. Nice to see everybody here. This is a wonderful conference. I've been having a great time. Just to tell you a little bit about me, I'm CTO at Mimoto. I've been in the software industry for about 24 years or something at this point. Started off in a really obscure programming language at IBM. Since then, I've worked on a wide variety of things and been a part of about 5 startups in a variety of roles, everything from a consultant to a founder and now CTO. One of the things in getting ready for this, I looked up the definition for platform engineering, and this is an excellent definition, very precise, but overall, my view on it is just that it's thinking very seriously about your environment that you build for yourself and treating that as a product that you want to enjoy as you consume it. So, developing internally in your organization should be a pleasure, not a burden. So, with that said, I kind of thought it'd be fun to start this off with some gripes. Let's talk about some things I don't like or I don't enjoy and haven't enjoyed in my career. And the first thing that I don't like is onboarding. So I don't know about you, but if you've been in more than one organization, or even if you've only been in one, you've either been onboarded or you've watched other folks get onboarded. And I remember one time I went to a company, it took a week for most people to get an environment set up where they could actually develop. I remember working with that team, we got it down to 30 minutes or something. So you just did a git checkout, stood up a Vagrant environment and got running. And that just kind of shifted my whole perspective on what could be possible to really tool up an environment and make it easy to integrate as a new person. Because typically the way the experience is, you show up and you're just looking at a maze, right? And a few people kind of give you a bit of pointers about which direction to go, but it's kind of up to you to figure out where you want to get to when it should really look like this, right? Somebody should be helping you step up onto the platform. Another thing I don't like is repetitive labor. Now, we all have to do things that look similar to what we do day to day, but consistently doing the same thing over and over, I think it just gets boring, first off. It gets dispiriting. And you start wondering, again, is there something I can do to make this better? I also don't like mysteries. As somebody who's had to support production environments and products that are available in the commercial marketplace, getting those messages where it's kind of, something weird has happened and you have no idea where it came from or what happened, having to dig into that's a real stressful situation. So really, I don't like stress, but stressful mysteries are the worst. And then there's surprises. the kinds of things that you could have anticipated, but you didn't. You just didn't take the moment to sit back and think about it. And so instead, you know, the guy that's prone to popping balloons behind you is back there with a paper bag this time. So what's my point? Your internal development platform determines all the things I don't like. And I suspect you don't like them either, right? Onboarding experience is determined by your internal development platform. The repetitive labor you're obligated to, whether you can avoid the mysteries and whether you can miss the unnecessary surprises. With that said, that means then that it also limits your ability to do what you're there to do. You know, you're getting paid to do a job. You're being kind of rate limited at 5 kilometers per hour because you can't plan, you can't execute, you can't deliver as quickly as possible because the platform doesn't support it. The flip side is that you can improve it, right? The internal development platform itself can accelerate your ability to deliver. So the good news, I promise everybody in this room, if you're doing software development, you are contributing to your internal development platform. The problem is, are you doing it well? So does this picture say don't pull, push only, or don't push, pull only? Especially if I'm, you know, maybe colorblind. So I think this all starts with a key question. Did you make it repeatable? Now, I want to be really clear. When I say repeatable, I don't mean an intern given 4 weeks and, you know, enough resources and time to go talk to everyone can reproduce what you did 5 minutes ago. I really mean that it is discoverable, right? It's documented. It's an efficient process. It's extensible, meaning that as new things need to be implemented, and it's repeatable, that it's easy and folks can figure out how to contribute. And it's debuggable, right? Is it throwing off information that gives you insight into what is actually going on when the application is running? So first point to the documentation. I kind of talked about, you know, discoverable and you know, gives you the appropriate information. And here we've got a really great image, right? Somebody goes and they find the documentation finally. They've been searching for it for years, finally found it, and it says, we should totally document this. That's just not the experience you want to provide. Another example is, you know, from an efficiency standpoint, sure, these 10 steps will totally get you where you want to go, right? Or it'd be much easier to say to someone, just do this one thing, and then you can get working. Now, I showed some anti-patterns a minute ago, but I really like the idea of a dongle as an example of extensible. You've got a very clear set of inputs or places where you can plug things in order to add to your environment. You know, I can just slug the HDMI cable right into my laptop and off and about I go. And finally, debuggable. Now, this image kind of is backwards, right? It's actually saying that, you know, 6 hours of debugging will save you 5 minutes of reading documentation, but I think that's the flip side, is that 5 minutes of reading documentation, presuming you can find it and it's available, can save you 6 hours of debugging. So repeatable, you know, when I kind of put this together, I realized that it spelled deed, and then it just felt like I couldn't help myself. It just fit in, right? Platform engineering is performing good deeds, flat out. So having claimed that repeatability is the key here, how do you make things repeatable? Well, I'll claim that you can start from the bottoms up, and I'm a software developer, so my version of bottoms up is, what do I have to do when I'm at the keyboard? So I think it starts with the developer environment. How do you tool that environment to make it easier for someone to get their job done? Well, first thing is kind of document how you do things. Don't just do things and then show people where your code repository is, because that doesn't necessarily give them the information that they need. There should be, you know, more than just a README that says, you know, at some point we should probably talk about how you actually stand this thing up. Most environments I've seen are pretty sophisticated in how you actually build the software. Provide tools. Now, this means that when you've got that README, it doesn't just say, you know, run this makefile. It says, run this makefile to learn about what's available. Here's something you can do on the first step. The key is kind of that mise en place principle, right? Have the tool where you need it, when you need it. Like this beautiful toolboard here. Now, this image that I'm showing here just kind of shows that idea of pluggability, but it also just kind of harkens back to my childhood. I had a Genesis myself. I think this is a Mega Drive, but they had this really crazy tower of power where you'd plug these different things in and you just kept extending the capability of the system until you went from 16 bits to 32 bits with some additional capabilities. Mind-blowing at the time. And finally, logging and debugging guides. So it's not just about adding the hooks so that people can actually investigate and understand what's going on when they're running your stuff. It's also providing them the travel guide, right? Help them walk through it so they can understand why you put those logging messages there in the first place. Now, as we go forward, I'm going to get a little repetitive, so I'll just kind of fly through the slides. But my claim is that every one of these steps actually lays the foundation for the next one. So if you've automated the development environment, that means you've provided some amount of scripting in an extensible way that kind of makes it so that you can automate things at the workstation. Well, if you've automated it at my laptop, now it's just a small tweak to automate it up in my CI/CD system. Oh, one more thing. I've been thinking a lot about platform engineering and its relationship to DevOps, and I've been using the analogy that DevOps was all about kind of building an assembly line, where where platform engineering is more thinking about the whole factory. You know, how does everyone in the factory interact with your assembly lines? And kind of really thinking about the flow of people and materials. But the principles that underlie automating your build system and your deployment system is the same as it is for automating the development environments. Document it, provide tools, enable extension, and make sure that it's observable. Help people understand and get an x-ray when it's running, and so that they know where to start when they're looking for a problem. Now, this image right here for the deployments, this looks like a bunch of containers. What I love about this picture is it's actually a library. This is the library at NC State University in North Carolina. You go in, you type the book you want, and a little machine goes off and retrieves the book out of a container and brings it back to you. Or if you're returning it, same thing, right? It puts it into a container, takes it and puts it back. It's kind of like watching a CPU in action. But it really wonderfully illustrates that notion of an automated deployment. You say what you want, it goes off and figures out how to schedule the movement, does it, brings it back to you. And again, same principles. So monitoring and reporting, I think we've all been in a situation where someone's looking at us, asking what went wrong, and you know, nobody wants to be in a position where the best they've got is probably aliens or something, we're not sure. And again, same principles. So kind of going through that, that's all talking the talk, right? So how do we walk the walk at Mimoto, and what does that have to do with OpenUK and open source? Well, my contention would be that, you know, for a small team or for a startup, open source allows you to punch well above your weight. You get to leverage platform engineering from the community at large. So I've got a platform engineering group, you know, numbering in the tens of thousands at this point, if not larger, because I can pull from resources that the community has built. So in order to kind of place that into perspective, I kind of have to talk about Mimoto a little bit. And so I won't talk about breach detection and response, but I'll talk about our three main components. We have a variety of software agents that run on the server or on a device, local on the machine. We have a cloud ML and data science engine that kind of collects data, or actually collects data from the agents, also shares data with the agents so they can perform their job. And then finally, we've got a web application that enables customers to manage that and see how things are performing, get alerts, configure policy, etc. So developing for this broad array of environments and needs, for a tiny team, you know, we need these tools. The tools we happen to use, we use JupyterBook, which is a real strategic choice. It enables us not just to document things and explain things, but we can actually make them interactive. For example, if we are doing an analysis on data, we can launch a notebook that allows someone else to perform their own analysis on the data and modify the breadcrumb that somebody left behind. The next thing, we use Python Invoke to make things efficient. So how do we make it so people can discover how to run a build, how to deploy the agent, new versions of the agent, how to do all the things we do in our day-to-day jobs? Invoke gives us a way to kind of provide a catalog. So you can just say, list the tasks, it gives you an idea of it, and you can go and explore and see how those are implemented and how we've automated our environment. That became necessary because of the next tool, actually, Vagrant. Given the wide variety of operating systems that we target with the agents, we want to be able to make it so you can just say, you know, stand up an environment for this target operating system that we support. But there's a limitation on the Mac with libvirt. I ran into this is something like 24, or I think by default it's 12, max virtual machines within a Vagrant file. So we had to break it up. If you have to break it up, well, now you've got to figure out a way to make it easy for people to navigate. I could document that there are, there's a way to do this where you specify the Vagrant file on the command line, etc. Or I could make it really, really simple so that all I say is task Vagrant up operating system. So that's what we've done. In addition to Vagrant, we have Docker. We use that for a variety of things, everything from deploying a web environment to setting up a build environment for when we're targeting a particular operating system. And then PyTest. On the debuggability side, I'll say I think unit tests or other tests, whatever you want to call them, integration tests, these are key in documenting what's the expected behavior and giving people a place where they can go find, when something breaks, they've got a starting point and understand what's going wrong, and it becomes a repository. When things break, write a test to make sure that it doesn't break again. Now on the CI/CD side, it's all those tools. So, kind of reinforcing what I said earlier, which is that if you automate the development environment, you set the stage for CI/CD, because all of that work we do in Invoke becomes the basis for what we're going to do in CI/CD using GitHub Actions. Currently, we don't use Terraform, but that's in the roadmap, and I think I'll say right now, my hope is to get to something like Cradix. And on the monitoring and reporting side, today we just take advantage of what our cloud provider offers us. Longer term, that's not going to be sufficient. It's sufficient for today, small team getting started. We're looking at something like OpenTelemetry when we're ready to take on more of that observability on our own. So what is platform engineering, or what's the key thing? Make it repeatable. Do it from the bottom up. Do it with open source tools and the consistent application of good deeds. Thank you.
It's for David. Somebody go on, have a question.
I did prep a little demo. So if folks would like to see, I don't know, I talked about Python Invoke. Something very, very simple. Is that, oh, yep, we can make that bigger. So very small set of things, but the key thing is that we've got some things that we have to do on a regular basis, just automating that. So very simple Python scripts, you just list out the things that are possible. Now, this isn't everything. This is within one project. One of the next things we're doing is actually trying to make it so that across the different repositories that we've got, you'll have a kind of master repository that you run the tasks from that repository, and it'll allow you to explore what tasks are available elsewhere. That way, any given repository can advertise, get set up with the cloning, etc. And so all you have to do for discoverability is just check out one thing and then start asking it, interrogating it, what can we do? And then go from there. Very simple demo. I'd show you the code, but. Any other questions? Actually, yeah. So very simple.
Okay. Oh, I think I do see a question. Is that a question?
I'm just thinking about it, so I don't have it yet.
Okay, we just need to think about ourselves while this, or talk amongst ourselves while this question is formulated.
Sure.
I think
Back there?
The talk title was the Lion Helm of Platform Engineering.
Yeah.
Can we bring you a mic so everyone can hear, particularly folks watching online as well?
Oh.
There we go.
I wondered if you could just give us a few sentences on the why. I mean, I think it's sort of embedded in your talk, but yeah.
So for me, the key thing, the key why behind platform engineering is making the development within your organization as smooth as possible. So from coming up with the idea through deploying it into production, making that process simple straightforward, pleasant, and repeatable. I think a key thing is making it repeatable again. Without the repeatability, you're dooming yourself to a lot of pain and a lot of repetitive suffering.
Now I have my question. So you're a small growing startup, and when you look at DevOps, S3, and the CI/CD pipeline, usually if you look at big companies, then you can say, oh yeah, they have the team to actually invest the time and effort. But as a small company, you have to think about where do I allocate the resources and what's the priority for me. And you can say, yes, this is a good investment, but it takes time. And maybe I should focus on maybe on sales or building the product itself or customer support. So it's much more difficult to actually have an established DevOps, and maybe your pipeline, your processes change within a short period. So what were the main challenges for you in terms of implementing a solution, or what do you think is blocking the implementation, if there is something like that?
We'll talk about Mimoto first. I think at Mimoto, I've got the benefit of kind of making the benefit the cost-benefit trade-off decision to some extent. You know, it is a team discussion, but we've got the ability to move fast and choose. We are resource constrained, but as I mentioned in the talk, I think the key thing is that there are a whole bunch of tools that people are out there developing, and so taking a few minutes to go and see, has someone solved this problem that I'm having? You know, is there a tool that can make it so, for example, I don't want people to have to think about configuring libvirt on Mac OS in order to get our stuff running. I want them to be able to get running as quickly as possible. Thinking about that and doing some research and realizing, well, there's this thing that we're already using and testing because we need to interact with SSH shells. So Invoke was actually a part of a PyTest setup that we put together. And then realizing that combined with Vagrant could make it so that we could just arbitrarily construct the command lines. It took a little bit of just poking around the web and asking different questions with variations on here's the environment to both have the seeds of the idea and see where other people had already had a similar problem and solved it by having these kind of high-level configuration scripts. Within a larger organization, because I've also been in the larger organization, I think what you have to do is kind of talk about, when you're talking with the executive team or the sponsor or whatever, you know, what is the situation? How much time is being wasted trying to, having people figure things out repetitively because they're all figuring out the same things, and how much time is being wasted just everyone reinventing a part of the wheel within the organization. If you can make that case for here's the situation, here's what I recommend, and then provide any additional information that would help clarify that, I've seen that work pretty well. It's just really giving folks the information they need to do the cost-benefit analysis.
And following up on that, when you actually also need to invest time and research the tools that you're going to apply, and how much burden, if that is a burden, is that a burden itself? Because even maybe the tool exists, you need to source it, even if it's free or open source, and research it.
I'll say within different organizations, I know the cost of adopting a new open source technology can vary pretty wildly. There has been a pretty big shift in the industry toward open source program offices that can help teams with adoption of open source products within their organization. I think a decent rule of thumb that I saw on someone's blog post, I wish I could name it here today, was they look at reinvesting about 10% into refactoring and other kind of supporting their own consumption of their own product internally. And I think as a way of thinking about that, that seems like a pretty reasonable thing, about a 10% investment, or at least come up with your own number for what the organization thinks it can bear, and then try to keep track of it so you can justify that investment later on and show that it, just like any investment, it should compound, right? The benefit should vastly outweigh long-term what you put in the short term.
before we break for the break, I have a question, a couple of questions for the audience. So first of all, can you raise your hands if you consider yourself either formally or informally to be on a platform team at the moment? Yeah, that's probably, what, half of you? Okay. And how many of you are at organizations that are thinking, yeah, we need to be doing this platform engineering thing? Yeah. Yeah, okay, great. Thanks very much. So unless anyone has any last questions for David, we will be back here at 4 o'clock with some more excellent platform engineering talks. Let's give David a big round of applause.
Thank you.
Go and get some refreshments, and we'll see you back here in just over an hour. Back after the break. Welcome back to the platform engineering track. We have 2 more amazing talks for you this afternoon. And the next talk up is going to be by Debbie Wood. She is a senior infrastructure product manager who's been working in software for 16 years and 6 years of experience working in platform as a product. So who better to talk to us about needing a PaaS experience on Kubernetes? Take it away, Debbie. Thank you. Let's give her a round of applause.
Everybody. Hello. Okie dokie. So I have put together all that we learned in the 18 months that we tried to do what we thought was impossible and managed to get it right. So I hope to leave you with, if not a game plan, but certainly the open source tooling that bootstrapped and cut 30 to 90, 30 to 90, but a fair whack of the effort out of the equation and set us up for success. So good afternoon. So help, I need a PaaS experience on Kubernetes, so platform as a service experience on Kubernetes yesterday, also known as my production environment is a ball of mud and possibly on fire. So the original title of this talk was Paving a Path. We're talking about the application developer's deployment path to production. I'd like to frame this as a case study, what we at a past employer set out to do and what we achieved. And I'll share what worked and then give, as mentioned, pointers to the particular open source tooling that was very helpful. Or at the very least, give you a sense of the complexity and the size of something of this, impact to an organization's coding, behavior, and their culture. So our aim was to help R&D go fast, to unlock new territories for the company by quickly spinning up new production environments. So we had an established United States data center hosted SaaS application. For people in Europe, it won't be a surprise to you to hear that there are European countries that cannot use SaaS software hosted in a US data center because of data residency sensitivity. So we had a massive backlog of millions of sales deals that were blocked because we did not have SaaS hosted in the EU. And that was that was all the political capital that we needed to do this work to enable us to reproduce what we had in GCP in the United States and establish the same functionality hosted in AWS in Europe. So when I refer in this talk to Polaris, it will be in reference to our internal project name. We established a very thin platform as a service API across several Kubernetes with very little code that we ourselves had to write. We just had to design conventions and then leverage open source to make those things real. Let me go. So a bit about me. So as mentioned, 16 plus years as an engineer, did a master's, discovered that product management is a thing and important because you can end up spending a lot of time building something no one wants. And in one of the companies I worked for, Pivotal, there was an opportunity to step into a product management role in a platform team, and that was all I needed. So that was an open door to doing something that I care about, is making sure that sorry, did I hit the wrong button? No, I think
I don't know what happened.
Oh no. Just check the...
Yeah, that was escape, yeah.
Teething issues.
Oh, wait a minute.
I don't know. There we go. Go to back.
Yeah, but I need to grab this now.
Okay. Deadly. Okay, bravo. Thank you. Okay, so yeah. software engineer for a while, PM for 6 years, doing platforms on Cloud Foundry and then on Kubernetes. So I saw how that world shifted. A bit about this talk. So as I mentioned, it's the story of Polaris. Polaris had a lot of impact on the organization, so it can be spoken about in many different lenses. We can talk about its component parts, its architecture. We can talk about the philosophical approach, like how much do you restrict your engineers? How much do you empower them? And most importantly, I think the thing that we learned was how you win hearts and minds. So you can go off in a dark corner and build something amazing. There's no guarantee that people are going to prioritize that and use that. So the art of internal developer relations showed its strength in this, in that we needed to make sure that not only were we doing it, but that people were seeing it, people were getting value from it, and that it was consistently used throughout about 30 R&D teams with around us in the company. So our 18 months of intense learning can't all make it into these 40 minutes. So I'm going to be selective and share what I believe could help you, particularly the open source that we used, as well as some of the more tricky learnings. So I interviewed the architects, the engineering directors, the managers, and the engineers of the infrastructure group that I was the product manager for, to give a sense of all of our shared experience on what we thought made this work, in the hopes that that helps you. So, over the places we will go. So that is Dorothy, the Tin Man, Lion, and Scarecrow on their road. And on reflection, for us to pave this path, it took a lot of courage, a lot of smarts and experience, and a lot of heart. It was very difficult. It was hard. And the chatty ones who drew attention to where we were going. I want to talk about what our cross-functional team at 18 months into this journey believe made this succeed. Success and buy-in involves storytelling, multiple modes of communication, forcing functions like deadlines, a couple of false starts along the way, if you learn from them, and a clear shared mental model. Not everybody in that company is going to be an infrastructure platform-esque engineer like we are. So some of the concepts and the terminologies and the concerns that we hold are not familiar to application developers, and they might never actually care. They don't necessarily need to know or want to know. So it's, how do I make sure that I give you enough to empower you to be independent, but obscure the things that you shouldn't really need to worry about. So today, I'm going to touch on the problem and the opportunity, describe Polaris and what a Polaris resource is, describe what we mean by a paved path. I'm sure it's familiar, but just for the avoidance of doubt. Do a very quick whistle-stop tour of our journey, so the timeline and the timelines we hit, and then the important, probably more valuable anchoring concepts, like what was the layers model that we developed, what guided us in technology selection. Open source is a big, beautiful universe of lots of shiny things, some of them abandoned. So how do you quantify and assess something that you can trust to build something like this on? The importance of socializing and driving adoption, as mentioned. You can build it, but no one is necessarily going to come. And then close with some learnings. Where did things get difficult? What worked particularly well? And what would we do differently? What's next for Polaris? And then finally, the links to the open source building blocks that we used and found great value from. So the problem and the opportunity. So when we're talking about 3 years ago now, the team was created, and it was one fearless engineering director, Crystal, and her 2 platform engineers. And they were running around, putting out fires in production on an estate that none of them had had experience building. And they were being the support personnel helping other people put out fires in their services in prod. So it was a bit wild in the beginning. 2 years later, R&D had tripled in size. So now we're talking 300 engineers with 2 support platform engineers and a director. And that, together with the growth and ambition of the business, meant that something needed to change, something needed to give. And that gave us enough political capital to actually get the investment to hire headcount, to get 6 very, very skilled platform engineers in the room who have done this before, and just that wisdom and experience of having done it before gave us the head start to not make some of the obvious mistakes. So we needed a highly repeatable platform. We needed to leverage R&D-wide conventions and practices to make it less difficult to operate. It needed to be fast and easy to roll out new production instances. We rolled out, a year after starting, we rolled out the EU footprint service offering. A couple of months later, we rolled out APJ, so Asia Pacific. The opportunity, why are we doing all this work, was the untapped total addressable market. So millions of dollars, euros of accounts were held back until we could get these things done. Okay, so what is Polaris? Polaris is an internal developer platform for managing numerous production environments. We present a PaaS-like interface. I think if you have ever worked with Cloud Foundry, the CF push model, we needed to replicate something as similar to that, but on a Kubernetes infrastructure without this massive investment on tooling built on top of Kubernetes. We didn't want that. We just wanted it to be as easy as possible for the application developers to deploy and not have to worry about the things that we will take care of. It's our platform as a product. It is an opinionated way of using the tools that we provide and enables repeatability, so the ability to make new instances quickly. We provide common open source tools, occasionally vendor software, and then most importantly, the opinionated way of how to use them. That's the thing that lets you go from 1 prod to 10 in 18 months, which is what we did. Polaris is successful not because we use something like Argo CD, it's because of how we use it. Similarly with Circle CI. These are common tools, but I think with a little bit of savvy, we were able to make it best support our use case. What else? Other examples that we used would be Terraform Cloud. Polaris supports the full software developer lifecycle, including bootstrapping, repos, build pipelines, etc., and touches on everything that happens after a pull request is merged. So what is a Polaris resource? Again, back to this model of our use case, our clients, our application developers. They're building things that run on Kubernetes, which is there be dragons for some of them. Others are, it's down to the individual, but really you want to take that cognitive load away from a specialist who is doing something else. So Polaris built the capability of defining infrastructure within your application Helm chart. Not through anything particularly sophisticated, but the fact that we were maintaining the Helm charts for things like an S3 instance or whether it be AWS or GCP instance of a database, all the application developer needed to know or care about was defining that they're using a Polaris database. That would pull in the appropriate Helm chart, and that's the last they had to think about it. Who owns or maintains these resources? Funnily enough, this is an important thing to get right, because I mean, I'm guilty of it. It's very easy to play with something and then throw it over the wall to someone else who now needs to run it and walk away. And the risk there is that you have a specialist team who are there building your Polaris, and suddenly there's a mountain of things that people have abandonware that they want another owner for. So we defined the practice that we will own anything that has like over 80% adoption in the companies. So a database, a Redis instance, those things are commonly used, we will maintain those charts. If you have niche things that you need to use, the creation and the maintenance of that would need to then remain with you until such time as there's wider adoption. So that ownership model was pretty key. So what do we mean by a paved path? A paved path is a well-trodden, well-supported, well-lit route to production to allow app devs to move quickly. As an engineer who writes application code, I want to write the code and ship it. Logging and databases should not slow me down. I shouldn't be caring about that. Things on the paved path are smooth, and they are signposted. There are docs, and there are people to help you. And what is the intent of a paved path? It's to make things easier, to reduce the toil, to create consistency, both for the application and the platform teams. Work being done by a central team means it's done in a consistent way. It's the same type of thing going out into production when it's instantiated. It lowers cognitive load for people both on dev time, so day 0, and on day 2. It's just, you know what you're running. The intent is to build, in the words of one of the engineers, the path from code to profit. So yes, ooh, is there like a short? Did that go off again? Sorry, I think there's something wrong with the adapter. Thank you.
Okay, I don't know what is happening here. But we'll quickly go to that. We'll do it again.
Okay. You're right.
I don't know what is happening with your computer.
Okay. All right. Thank you. All right. Okay, the universe's way of telling me to make it quick. All right, so I'll touch on this quickly. So we started work in May of 21. 5 months later, we had our first pre-prod. 2 months later, we had our first production customer. 6 months after that, we had our first European data center installation. So within 12 months, at the breakneck speed, we got there. So those are the external milestones affecting customers. Internally, we would have had the internal roadmap for the application developers. So I think this is probably where things start getting a lot more interesting. So the layers model, like I mentioned, we had 2 classes of specialists in the room. You have your application developers and everything that they care about, and then we had the platform engineers, and there was no shared language between the 2. And even within the info group, designation of some of the layers in the stack were ambiguous. So someone took the time to just sketch out a schema of how we understand all of these technologies and what it is that they take care of. So from containers down, for myself, maybe as an engineer way back, beyond containers, it starts getting murky for me. When I was even in Cloud Foundry land, I didn't really have to worry all that much about networking, so why do I need to worry about it now? So this just helped us at least have a handle on what it is we're talking about, so created that ubiquitous language. So just referring to the triangle on the screen there. So from the bottom, that would be RBAC, backup, audit, cost management. A layer above that is the cloud provider account and identity and access management. Above that is the network layer, above that is Kubernetes, above that is the APIs that we exposed as the info group. And then above that, layer 5, conceptually, would be where the application and service authors would be deploying their code. So tech selection. How did we choose what to compose Polaris from? So we had a very experienced team. These would be their second or third systems that they're writing. They know what worked for them. But where there was ambiguity, kicking the tires. So hackathons, bake-offs, assessing support contracts, how easy it is to get something done, how easy it is to operate. So only where necessary, where there was any kind of debate, we would have a bit of a go play with it and see exercise with a couple of the engineers. Kate's was the common denominator. So for the curious, what did we end up using? Usual suspects, so Helm, Argo CD, Terraform, Kubernetes, Docker, Prometheus, and vendor software would be GCP, AWS, CircleCI, Datadog, Backstage. A good example of one of the choices that we had to make was whether or not to use HashiCorp Terraform or use Crossplane. And in the end, we went with Terraform with the intent that we would give the application developers the flexibility to use Terraform if they so desired and not have to learn a new technology. So let's talk about, this is I think where we learned our biggest lesson. You can build it, but will they come? So let's talk a bit about the role of docs, demos, and onboarding in socializing and driving adoption. Not everybody has to use this. So you kind of need to, you can't be bullying people into using something that sucks. So there was an effort to get some pioneering teams, get some early adopters in the room, get their feedback and make the necessary changes. Those teams, we would have company-wide retros every 2 weeks, or not retros, sprint demos. And people would make a noise about their wins. And we initially started making a lot of noise about Polaris. We got adopters, and then they started making a noise about how this was making their lives better. And I think that very virtuous circle built the momentum of adoption and helped us refine and improve the product. One of the things we observed is not everybody's going to be absorbing information the same way. Not everyone's going to be joining those Zoom calls. Not everybody's going to be reading the Slack channels. So you have to repeat yourself, and you have to make sure that the message goes out across many different forms of comms so that you reach as wide an audience as possible. But it had to be deliberate. The change wasn't going to be accidental. One pragmatic thing we did, and I think it was a big one, was we just decided, given that we are the subject matter experts and we know exactly what we want you to change in your Helm chart, we're going to submit the pull requests for you to your repo for you to look, double check we didn't break anything, and then just accept it. So we wanted to save you the context switching and the cognitive load. So we were like, we'll do it for you, just accept it, and we were flying. And that meant that adoption was in a matter of a sprint as opposed to this long drawn-out saga of trying to train and teach people about technology they don't care about and changes that they would probably ideally not want to be making. Okay, so 5 slides to go. So where did things get difficult? Usual candidates, so deprecation. There were things already in place that people were familiar with using. They were not aware of where it was broken, but there were things that were significantly broken, and that tax was landing on us. So it was in our interest and in the interest of the wider organization to fix these things, but to get the political capital and the will for people to change things that they've been using was not an easy task. So deprecation, upgrades, and creating a shared sense of urgency. So this is my timeline, this is the organization's timeline being driven by infra, but the wider R&D organization has its own roadmaps and its own sense of priorities. So for us to influence that and change those priorities took leadership support. It actually took a bit more clout than we ourselves had. But that was a challenge to get that done. Case in point, we deprecated the original ball of mud deployer 6 months after its replacement had already been launched and was in place and being used by some teams, because there was just that people were holding on to something that they were familiar with and scared to step over the line. Okay. What did we find worked well? So the team being very cohesive and very experienced, they worked very well as a team together. I was the product manager and I joined after they had been struggling for a long time. And I think that the team needed a product voice to advocate and say no to a lot of people because the team was being pulled in a lot of directions. But ultimately, to see all of the conflicting requests being put on these people and make a decision and drive the picture forward, you needed one person to be that umbrella. Leadership backing us signaled that we had the blessing and the clout of very senior people in the room. And maybe slightly controversial, but that deadline of having a contract signed with the customer and an ETA of we want to move in January meant that these conversations stopped being woolly and abstract. It became very real, like there's a contractual obligation here. Program management, so we needed to coordinate effort across 30 to maybe 30 plus R&D teams and ourselves. And there's no headspace in a single engineer or a product manager to do that. You need a dedicated function for that. And above and beyond the pull requests. The layers mental model helped us all speak the same language, and choosing to not be overly restrictive and not force engineers down a road, give them the tooling to enable them to build their own. So we would give examples of Circle CI pipelines, we would give examples of various configuration, and we would give an example app of all of this working together nicely. I'm good like this. Anyway, I'm going to talk. So having done that, having decided that we were going to give you the demonstration of how to use this, gave a reference model for people to use quickly. You're going to have this down in like 2 seconds next time.
Hopefully it's the last time.
Hopefully it's the last time.
You said 5 slides, eh?
Yeah, exactly. Anybody want to put money on that? Yeah.
I don't. So I know I will be back here.
Oh, too funny. I'm just not going to touch anything.
No, I don't know what's that.
Okay.
It's all good.
Bravo. Okay, cool. Push the button. Okay. Yes, and the seniority of the engineers who did it. So they had been, this is not the first time they faced this particular mountain, so they had a great sense of what to avoid. I would add one more thing that I didn't put on that slide, and it's resist the temptation to start from scratch. That was one of the, had we tried to build all of these things from zero, I think we'd still be busy. So use the things that are out there that can use the open source that's out there that's going to make this faster for you. Do differently. Difficult question. Well, I got a lot of different answers depending on who I spoke to. So one of the observations was I'm not the person I was when we started. So I've learned a lot as a result of the effort. But given who I was there and what I knew then, I think we made the right choices and we delivered on time. So I wouldn't second guess myself. I think with the limitations and the pressure we were under, we executed and we got it done. We had to get this out the door very quickly. But given the luxury of more time, what would we have done differently? Probably a bit more customer research, been a bit more engaged with the application dev teams as they were starting to use Polaris for the first time. We kind of fire and forget. Well, we created the get pull requests, saw a green build, and moseyed on to the next team. We didn't really sit and absorb in a world where perhaps these teams would have wanted to take a bit more ownership, we didn't utilize the opportunity to watch and learn and see where to improve. We were just running for the hills, right? We were getting this done. So had we had more time, we would have spent more time coaching to get fast feedback. Where to next? So the future for Polaris will be, today we are building configurability so that in a world of those application developers, they might not even need to care about the Helm anymore. They can just give us the configuration rules. What is the size of the database you want? Do you have any kind of replication rules, etc.? Drop them in a service, give me your source code, and I will go and make one of these for you. So you don't have to express anything in, I didn't even touch it this time. This is amazing. Anyway, I'm going to click onto the next one. So the last slides are the cool slides. So these are the slides where you take photos, lads. So you're going to have to jump quickly while we still have a screen. So these are just the lists of the particular open source that we used, and specifically the capabilities of that open source. I'm going to give you the anonymized version of these things so that it'll give you enough to get the creative juices going anyway. Yeah. It's very Mr. Bean. Boink, boink, boink. Okay. You're awesome. Thank you. Cheers, dude. All right. So CircleCI, obviously, your build and deploy pipeline. CircleCI allows you to build something called an orb. That orb is parameterizable. So you can send arguments to that org, this is how we implemented things like canary builds, or this is how we will implement things like blue-green deployments across a fleet of Kubernetes clusters where we're like, it works here, I feel safe to roll that out to everything in EMEA. I now feel safe to roll that out to everything globally. So those kind of controls you would implement in an orb. Helm allows you to declare dependencies, and on the next screen I'll show you, it's not rocket science, but it was just how we used it. Once. Okay, so you are seeing there an example application, and we are declaring dependencies, Polaris Postgres being one of them, the alias is Postgres, and the repository is something external. That meant that we could designate that work to a separate team and just blindly use it by the consuming team. So any single resource can be implemented by us and then pulled in by an application team. So some of the pull requests that we might have done would have been something like that. So let me take this work out of your headspace, I will do it for you. You just run your service after you've brought in the merge and see that I haven't broken anything. Alrighty. So as mentioned, the value for us was in separating out the cognitive load. You don't need to care about your database, just tell me you need one, and I will make sure that it's there, whether that be on GCP or on AWS. Argo CD. Argo CD is gold, and I would highly recommend that you go read. So Argo CD, they describe themselves a GitOps continuous delivery tool for Kubernetes. They describe it as the intent that application definitions, configurations, and environments, I'm thinking back to that ball of mud, should be declarative and version controlled. Ooh, this is an emotional journey, lads. But anyway, another thing that they have, and there's a URL, so when you can take a photo, I hope you have, but it's called App of Apps. And that's a way, in a world of microservices where a lot of different teams are contributing code to different repos that together make the beautiful thing that you're building, the version of the code that's running in prod is identified probably by a get char. You need to know those things in an incident. You need to know what is running where. And App of Apps uses get chars to track what version of each service is running where, amongst other things. I probably can be corrected, but these were some of the tools that we used to understand the original ball of mud and make it understandable and reproducible, and then reproducible wherever we want, and done so quickly. Thank you. So yeah, have a look at the App of Apps pattern. HashiCorp, so the Terraform Cloud Operator, that's, let me read, they said it better than I can. It's a way to extend the Kubernetes, a way to extend Kubernetes so that you can use Terraform to build and provision cloud infrastructure. So you can create a custom resource definition, give it to the operator, and then tell Helm to use this particular CRD to go, please go build my database for me. So that was part of how we implemented, just the light touch. I'm an application developer, I need a database, I do not care how. That's how we made that work. Really helpful if I could, cursor. And then the last slide. Yeah, let me just read that for you. The Terraform Cloud Operator extends the Kubernetes control plane to enable lifecycle management of cloud and on-prem infrastructure. So it just gives you a lot more freedom. So have a look at that. I won't show you what we did because we were solving our unique business problems, but that should give you enough inspiration to get started. I did want to mention Kratix. Kratix is an open source tool that was built, started really taking shape after we had kicked off Polaris. Polaris is in-house and I think will always stay in-house. What I see in Kratix is they're starting to build those capabilities that we built in-house, and it's open source and you can use that. So if this is ringing any bells for you about pain that your users are experiencing, they might be able to help you. It looks very cool. So in closing, we got there, and the screen is on. All right, so in this Kubernetes as Lego IKEA world that we are now in, where you have to roll your own PaaS, you will need a solution that solves your internal developer community's problems. So this type of investment is expensive and disruptive, and it usually is an artifact of scale. This starts happening or being something someone's willing to part with money for is if deployment is getting particularly painful, which it was for us. It was becoming a nightmare. So it is most likely time when things are getting unwieldy to start hiring platform engineers and a product manager to start solving problems in order of priority and impact. So where do you start? You start, it's like going to a doctor's office. Where does it hurt? Where are you going to move the needle the most? And therefore, get goodwill, and therefore, get further investment. So you start there. I think we got there, lads and ladies. There we go. So thank you. I don't know.
Debbie, do we have some questions for Debbie?
possibly a drink. No?
Oh,
No, I'm teasing. I've got
I
water.
see on the far side.
Yes.
We've got a mic
Hi.
on that side.
Hi, Debbie. So it was interesting hearing what you were saying about communication and the different channels and different mechanisms to communicate out.
Yeah.
One of the things I think platform engineering teams that do exist maybe struggle with is understanding just
I
how
agree.
much of the effort budget needs to go into training, education, documentation. What did you see in your experience as a sensible amount?
You know, I think that was some of the earliest feedback that was being given to us as a team, and I think it's a factor of how busy we were, was that we were working like, dwarves in Moria. No one knew what we were doing. We had to learn to become explicit, and we understood that if I don't write this down in Backstage, I'm going to get asked the same question about 40 times today. So we started making that a part of delivery. So one of the acceptance criteria on our story would be there is some sort of a how-to, and that how-to would either be discussed at the sprint demo weekly. So it was built into every story is the short answer. So if it was customer facing and there needed to be some level of training, one of the acceptance criteria was there's a section on Backstage that describes the why, the how, and the who to chat to, worst case scenario.
But there's also a burden to maintaining that documentation, which has an ongoing impact. So how do you deal with that as well?
Great question. So we had our early adopters, so we had our champions who kind of were, infrastructure intrigued, and they would look through the Backstage doc. They would be our friendly teams, like the ones closest. They would give it a first pass and point out where we'd missed it or where we'd assumed knowledge that wasn't actually beyond this particular brain. So they were allowed to, they enriched the documentation that we launched with the things that they were learning and pointed out where it was stale. Then, together with that, we have spun up a developer experience team that steps up to that plate. So I think that answers your question. So like we initially invested in it where things needed to be corrected. It could be corrected by the users of the service. And there is now a dedicated function to make sure that stays up to date.
Any more questions? Oh.
It sounds like in platform engineering in general, you often have a product manager looks after the platform, right? Like you were.
I wish that was the truth. I think but continue with your question.
I guess my question was like, do you think your background in software engineering helped you?
Definitely, yeah.
And what skills would you recommend? And
someone looking into that place, I think, don't be afraid of it. Like I started as an engineer. I came into a platform team. The person coaching me as a product manager had never worked in an infrastructure domain. They had been working with things with GUIs or things with user interfaces and external customers. So she found it a bit like it was a bit of a mind twist for her to my end user is now a developer. But on reflection, I'm like, no, it changes nothing. It's the same practice. You're supporting someone's work use case, taking problems away from them. So I would say it's not a different animal. It's the same practice. It's the same practice of product management. It's probably going to be a bit of I would say if you want to go technical PM, that you should try and get some computer science in there, because otherwise it's just, you can very easily get intimidated about something that shouldn't be intimidating. So if you can do, is the short answer, yeah. Anything else?
Oh, I see another question back here.
Oh, cool.
Hey, Debbie, thanks very much for that. Maybe an unfair question. I'm just thinking about if you didn't have that business driver of like the new region, like pulling it all along, do you think you could have done it just in the US? That whole changing the behavior and the culture without that kind of big pull, and you were just told, here's the investment, try and make a different pile of mud?
We would have struggled. because that money driver was CEO, Chief Product Officer, and Head of Sales, and Head of Finance were all going, make it so. And all of the decisions that had to be made about what do we sacrifice in service of this were made consistently because they believed landing in the EU is worth it, landing in APJ is worth it. So I think we would have struggled, but I think we would have kicked the ball of mud a bit further down the road, but ultimately that ball of mud was going to bite someone in the ass. I'm not allowed to say that, but so I think it just made it faster. It made the need more acute, and there was a carrot rather than a stick at the end of that need. So it was driven by that. I think that was probably one of the reasons why we got the green light and we got it done. Yeah.
Any more questions? Okay, let's give Debbie a giant round of applause. Thank you.
Thank you.
And our last speaker of the day, I saw him arrive. He went to get mic'd up. I've lost visibility of him.
I'll tell you about it later. You're busy at work? You're busy at work?
Me, yeah. Well, I mean, I just come back from Boston yesterday.
Oh, of course, yeah, of course, yeah.
Just trying to catch up. Is Matt here?
Yes.
I thought he was in
And Stig. Wait, which Matt? Jarvis? Yeah, he's in.
I thought he was at...
Yeah, Seattle. Yeah, he's horrendously jet lagged.
Oh, he just got back from
Yeah. A couple of days ago, but he's suffering. Yeah. From his keynote.
Yeah, I saw it actually.
Yeah.
It's pretty cool.
Yeah.
Okay, so while Matt and his laptop get wired up, I'll just do a quick introduction. So I'm personally very excited to watch this talk, and it may or may not have something to do with the fact it says eBPF in the description, but that's just one word of a long description. So Matt is going to be talking to us about zero trust, also a really interesting topic for me. Matt is a software engineer at Tetrate, and I think he just got off an aeroplane this morning. So, big round of applause for Matt for bearing with the jet lag and being here with us this afternoon.
Yeah. Oh, I'm hot, yeah.
And how's it looking?
The Wi-Fi's not come back up. Other than that, it's looking, yeah.
Good.
I thought I'd be honest. About, I'm getting authed by Google because of course I am. Yeah, I thought I'd be honest about it. I am very jet lagged, mostly because a lot of this was put together on the plane because I was not expecting to do it, but I think it's good content. I think we'll learn some stuff.
Well done to Matt for stepping in at the last minute to give us what I think is actually going to be a very interesting talk to wrap up today's platform engineering track.
Thanks.
When auth allows.
Yeah, I guess I've just failed the impossible travel check, right? Because I woke up in Seattle, so there you go. It's getting suspicious. Security. Right, I will keep that. You can have... Where's my other monitor? Where is it? Left, right, up, down? I'm lost.
Okay. Oh, you want to just check it on extend?
I just want to check it. Oh, is it on mirror? Is that why it's all weird?
Yeah.
I feel like now is a moment. If anybody knows a really good joke,
this is really annoying. Yeah, it's really annoying they've changed that.
Yeah, and now we can just check it over there.
Whichever way it is,
and
there
make
it
full
is.
screen.
I know of it, and roughly.
Hey,
cool.
We're good to go?
Thank you.
All right, great.
Cool.
Round of applause for Matt.
Thanks, everyone. Thanks for coming, even though I think I was only on the schedule as of about 20 minutes ago. Yeah, I think there's going to be some good content in this that's hopefully interesting and useful. It will not be the smoothest presentation. The talk starts with a story, like all good talks should, but the meta story starts with me being asked to present this content when I was hanging out with my friend yesterday evening except that friend lives in Toronto. But here we are. So I want to talk about zero trust. I've called it zero trust beyond the buzzwords because I think there's a lot of hype and a lot of buzz around zero trust, right? Zero trust architectures and what that means, and a lot of vendors trying to sell solution, and a lot of marketing that's kind of lacks on the details. So I want to go through essentially some sort of definitions and some bullet point lists that can help us understand this more. I'll touch on how we might implement it, but this is more going to be sort of stepping back and thinking, what does it mean to have a zero trust stance? Mostly on the network, but I will talk about compute a little bit. The abstract promises a lot of compute. I didn't have that much time, but I'll talk about the compute side of things a little bit as well. So if we think about a traditional network, maybe Bob is running a network. This is exactly, how he was told to do it, just like the book said. These are the best practices, just like the vendors told him to build this network. So you've got a firewall and a DMZ, and then there's another internal firewall, and you can hang some subnets off that, but actually firewalls are expensive and maybe a bit slow, so most subnets get just hung off a core router. So there's absolutely no access control between the things that are just routed, right? And then there's sort of subnet to subnet access control, maybe IP to IP access control between the things hanging directly off those expensive firewalls. The problem is, some bugs are so bad they get logos. So these were meant to come in one at a time, but we've got a shell shark and a heartbleed. Apparently that's the official Log4Shell logo. Oh, wow. Apparently it's what happens that's what you get if you Google it. And then your Cisco Edge device might have a 9.8 because it just has a default root password. Your Fortinet, not to pick on any one vendor, your Fortinet Edge device might have a 9.8 because you can get full remote code execution pre-auth with a misformed packet. So you kind of have to assume that the attack is already in the network. This post-it note here came out of the Snowden leaks, actually. And this was the NSA's drawing of how Google works and where they were inside Google's network. And the little smiley face is them complaining that Google has the audacity to put TLS on things in some places, but not everywhere. So this is how Google found out that there was an advanced persistent threat inside their network. And all of those adjectives are actually sort of applicable. So, it's not really Bob's network, maybe it's Eve's network, right? And if your attacker's already in the network, then, as I say, there's very little security inside of these things because you've got past that edge, which is where we traditionally do security boundaries, right, and trust. So if you're in one app, you can just talk to another, and there's often nothing to stop you. So trust no one, right? We have to labor under the assumption that the attacker is already in the network, right? They are advanced, they are persistent, they are probably threatening us. So that brings us to doing zero trust. But what does that actually mean? So maybe Bob can go and build a better network, right? So this is kind of what it looks like now. And the difference is those sort of central firewalls have gone, and what we've got is a policy decision being made and being enforced at every hop, right, at every possible request. So for every pair of services that want to talk to each other, we can make a policy decision and we can enforce that policy decision. So that looks like a PEP, a policy enforcement point, with every app, right, whatever that means. So there's essentially a firewall everywhere, right? Everything you kind of have to treat like it's the front door, and it's no longer good enough for traffic to arrive from a privileged position and be trusted, because privileged positions don't mean anything anymore. In fact, there aren't any. That old perimeter model's dead. And importantly, with the more modern technologies we've got, the policy that we want to apply for this can be codified and automatically, enforced everywhere. So what are the principles of this zero trust, right? We need access control between every pair of services that is least privilege. So, any workload can only talk to any other workload that it's meant to, right? It sounds obvious, but if you don't have any kind of policy enforcement, if you don't have any kind of firewall between a particular pair of services, you just can't do it. So any request that tries to follow one of those, routes that isn't ordained is either a mistake or it's malicious, and both of those need to be blocked. And in order to do that, like I say, you have to, get down to enforcing policy everywhere. It also has to be per request. So this is sort of least privilege in time rather than least privilege in space, right? One request from a workload to another workload might be valid, but then the next one isn't, because it might be a different operation, your access might have expired, there might be a rate limit to avoid, sort of DOS scenarios, that kind of stuff. So no more setting up a flow and just leaving it, so no more, network 5 tuple of can this TCP port talk to this TCP port. So that means whatever's doing your inspection and you're making your policy decisions has to understand what it's seeing on the wire. It has to actually understand the protocols. Maybe you've got gRPC in HTTP2 in TCP. If you're going to do per request, you need to be able to pull apart that HTTP multiplex, and you need to understand the semantics of gRPC. What's a read and what's a write, and what endpoint, what gRPC service and method are you targeting. Access control needs to be identity-based. So it's no longer, based on the location, which you might try to identify by the network or the IP. We have to give it a strong, cryptographically strong identity. We have to give that identity to something, and I'll talk a bit more about that later. And it needs to be context-based as well. We need to be able to make those decisions about whether we allow something with a little bit more context rather than just A is trying to talk to B. It might think about previous requests that have come in. It might know about the state of the system. If we combine all the techniques I'm going to talk about, then you can say something like, well, the back end can talk to the database, but only if that request came to it via the front end, and only if it's on behalf of a logged-in user who has a particular read permission, right? So we're talking about the machine identity there. I'm skipping ahead a bit. But we're talking about the sort of machine identity of back-end and database. We're talking about the user identity of, are they logged in? Who are they? What scopes do they have? So what are we trying to do with this better policy? Well, we're trying to bound attacks in time, kind of skipping ahead to the implementation here. If you can steal some creds, often you can replay them. There's a lot of cryptography, a lot of advanced, clever security people, have stopped various of those attacks. But still, if you own a workload and that workload has creds, you can impersonate that workload. So automated issuance of certs or whatever your identity is going to be, and automated fast rotation of them to sort of bound these attacks in time. So if you get into a workload, any creds you steal, any impersonation you do won't be valid for very long. And then bounding attacks in space, which is basically preventing pivoting, right? If I get into one workload, I then can't move laterally. It's as old as time, but you have to have all of these previous things, because all of these things actually say, well, what is a valid request from one service to another? Nothing else counts, and anything else is just a potential vector for lateral movement that we want to block. So how do we, sorry, first time I've been through these slides, no idea how long they take. How do we control for this, right? How would we enforce this? So one of the main ways we do that is at runtime, right? On the network, because we are talking about network requests. So if there were sort of 5 pillars of zero trust architecture, I think it's this. This is hopefully trying to get beyond the buzzwords to what do we actually mean. So we need encryption on the wire of these requests. We need service authentication. I'll go through all of these. We need service-to-service authorization. We need end-user authentication. And then we need to authorize the end user to a particular resource. For anybody who's not familiar, authentication is sort of, who am I? It's my, I've got my passport on me. I wave my passport to prove that I'm Matt. Authorization is, well, now I know who you are you allowed to do something? So does your passport contain a visa for this country? It's all very good that I trust you are who you say you are, but you're not allowed to enter Australia. So this encryption on the wire, well, this prevents interception. Data might be sensitive. We might not want them to be read. It also prevents tampering, because all of the other controls, all of the other claims are useless if you can't trust the bytes that have been, coming over the wire. So reading the data is bad because you might steal sensitive information. Reading the metadata is bad because I might be able to steal some creds and replay them. And if I can tamper with that data, I can break your system, and if I can tamper with that metadata, I can bypass your access controls, probably. So once we've got that foundation, service authentication, so one service knowing who another service is. So by service, I mean sort of a workload, like the sort of machine identity. So yeah, this is workload to workload. Like, can the backend talk to the DB would be a kind of access control question we would ask. And you can couch that in standard, like RBAC, right? So you've got your, it's basically verb, it's basically object, subject, verb, right? So you've got your, what would Amazon call it? Your principal and your action and your resource. But those 3 things, can the backend talk to the DB? There are some standards, again, skipping ahead maybe to how you'd implement this, there are some standards for encoding this kind of thing. Spiffy is the main one and talks about a way of making minting IDs for workloads with a bunch of useful properties that I don't really have time to go into that can then be embedded into JOTs, into X509s. You know, it's implementation agnostic, but they've got some reference ways of doing it. Issuing these things should be a really high bar. I'm going to come on to that, but this is where a lot of the heavy lifting is done. Because obviously impersonating a workload is quite a common thing. This is why we have SSL on the internet and so forth. Once you know who the workload is, then we can talk about authorization from service to service. You know, we know we've got the back end of the database. Can one talk to the other? Can one perform a read operation, a write operation? End user authentication, you know, this is, I guess, fairly straightforward. You know, do we know who the end user is? They're probably not going to, you know, if you're in your browser trying to buy some tat for Valentine's Day, you're probably not going to present an MTLS cert, right? So we're probably going to log them in, and then that OIDC flow will exchange that for a JOT, or you've got some way of identifying the end user. And then when we know who the end user is, we can authorize them. But we don't talk about authorizing them to the workload. It's not, can this user, you know, can I talk to the database? Well, of course, you know, requests on behalf of me, requests when I'm logged in can talk to the database, but that's not really good enough because I shouldn't be able to read somebody else's records. I shouldn't be able to perhaps even write to my own records. You know, I shouldn't be able to set the balance on my credit card higher. So we need to talk about authorization of that end user in terms of resource. So the nouns and verbs of your application layer, of your business logic, because that's what you're trying to protect from humans. The other places we put controls in to get this zero trust is the sort of the people and the processes. So yeah, I said the minting of these workload identities. Sorry, there's a lot of text on this, not the smoothest presentation. But essentially saying that if I'm going to give, you know, back end one of these Spiffy IDs or something that identifies it that lets other things believe who it is, well, what do we need to look at? I need to look at verifying the machine that this thing is running on. So on an on-premise server, I might talk to its TPM. You know, cloud provider VMs have got identity documents. A phone's going to have a device ID. You know, those things are sort of cryptographically quite strong, sort of untamperable. They're a challenge response chip on the phone, I think, right? You can't sort of extract the key from them. So we need to know what machine it's on, because this is, you know, if I think that a copy of the very important ledger service is talking to me, well, is that running on our server in our SCIF? Or is that running on a random Chromebook in Russia? Because that's actually really important. It might be the right binary. You know, things get stolen. The attacker's in your network. It's a really important distinction. And you can do clever stuff like sort of impossible travel detection, which I think I just failed. You then also need to look at the human, not the end user, but the human that's trying to execute this workload, right? Before you mint this thing in ID, you know, have they verified their credentials recently? What device are they on? What location are they in? Have they been fired? You know, your offboarding procedure should very quickly shut down somebody's ability to check in code, to build code, to interact with CI, and to run any of your binaries. At least, not to like / run them, probably, but to run them in such a way that they get minted, a cert that actually means something. So yeah, do they have the permission to go through all of those steps of the build? So if I do a git checkout, if I've done a dev build of something on my laptop and I try to run it on a production server, I mean, maybe that probably works, but it should only get a test ID. Likewise, if I've managed to get my hands on a production binary, a production build with all that attestation that's come through the CI system, but I'm running it on my laptop, it should only get a test ID because it should be restricted in what it can do. Only a production build on a production system should have the full production access, because you know to get that build onto that system, you've got to go through a bunch of gates. So then you can issue it an identity you probably actually trust. Some of these are maybe a bit blue sky. It's not obvious for me to tell you how to go home and implement them straight away. I know it is possible. Like Google does all of this stuff. I'm sure other companies do as well. Off the top of my head, I couldn't tell you open source projects that get all of them, but there's standards like Spiffy and OAuth and JWT behind all of this stuff. And YubiKeys are great and whatever. And then you actually need to verify that binary that you're running, right? I've verified the machine that it's trying to run on and the human that's trying to run it. This is where we get into more of what I'm probably going to talk about later, which is, well, what's the build signed? Does it have an SBOM? Was that SBOM signed so that I trust it? Is that SBOM, what's an SBOM? It's just a very long JSON document. Is it within policy? Does it actually contain violations that I care about? So how might we implement this? This is just going to be a slightly quicker one. It's not really what this is about. You need to get that implemented. You need to get that policy decision and policy enforcement, and they can technically be separate. Like all the academic literature refers to PDP and PDP, policy decision point and stuff. But you need to, usually they're the same thing, you need to get them with every workload. So there is obviously many ways to skin a cat. The obvious ways of doing it are either some kind of fat client library like Spring or gRPC, that's got auth middleware, auth-n middleware, auth-z middleware, knows how to talk at MTLS, or you have your app be done when you use a service mesh like Istio or Linkerd. In terms of the service mesh, I just want to mention that approach because they're Kubernetes native and quite easy to operate in a cluster, but they can also run on traditional hardware. So if you've got stuff on VMs, you have to go do your own plumbing, your own IP tables and whatever, but you can get, in Istio's case, you can get an Envoy and you can put it on VMs, and it can then be the policy enforcement point for more traditional workloads, and you can get them talking to each other under this unified, control plane, under this unified policy. So that, the same would be true of gRPC libs, right? But you're probably retrofitting stuff, especially if you're going onto legacy hardware, traditional hardware, sorry. Try not to insult anybody. So maybe a service mesh is the way to do that. I do have to pay my rent, right? So I work for Tetrate. If you do go the service mesh route and you take Istio, you will hit scaling problems with it, technical scaling problems, people scaling problems, policy scaling problems. We make a management plane and a nice abstraction that will save you from that. Right, this is the bet that we've taken in this technology space. You might also be regulated or want to meet certain standards, and all of this stuff is very useful there as well. So the US federal government's actually done a lot of work in this space. There was an executive order from the White House, I don't know if the White House spokesperson's in here, on improving the nation's cybersecurity, which is basically saying, please do microservices, microsegmentation, zero trust. And then NIST came out with some special publications kind of telling you how. So 207 talks at a high level about zero trust architectures. 204 tells you what a microservices system should look like. And then 204A specifically says, right, here's how to use a service mesh to do that zero trust using microservices and using a service mesh. And there's even a mapping in the appendix between all the controls in 204 and like the Istio features that you want to go and toggle on. So if you're subject to regulation that's telling you to do this stuff, or you just want some guides and some guardrails, then there's actually a lot of quite practical advice out there, especially in 204A. It's probably better than you think. And then, I know we're in the UK, but the US banking regulator, FFIEC, basically just adopted NIST 800-204 wholesale to tell banking how to do it. They took that as a good reference. I'm steaming ahead of time. I didn't bother to pull the demo out. Well, I wasn't brave enough to get the demo out. Oh well, you'll have to listen to me talk. So on the other side of zero trust, right? So I think we've had the obvious definition of don't trust the network, right? And hopefully I've gone into what that actually means in terms of you need encryption on the wire and you need service and end user, auth-end and auth-z. But we can't trust compute either, right? We have to have sort of zero trust on that side of things as well. So beautiful 4 a.m. diagram here. This is a container image. What's not to trust about a container image? Well, first of all, it's the computer it's running on. I've touched on that a bit. I won't really have time to go into this, but it should be, if we've done the architecture that we talked about before, it should be protected from its neighbors. Other workload. If you run this container image on one of those servers, say in a Kubernetes cluster, other workloads in the system shouldn't be able to talk to it, because we've talked about the sort of pillars of zero trust across the network, because that's how they're meant to communicate with each other. But there's always side channels, right? It doesn't protect you from that architecture doesn't protect you from noisy neighbors trying to DOS you. It doesn't protect you from any of the more privileged parts of that system, like being owned, right? So the Docker daemon or the kernel or the libc on the host or the BIOS, or any of that kind of stuff. So we have secure boot and we have TPMs and we have all of that good stuff. Not really the topic of this, because what I wanted to talk about was trusting your supply chain or not trusting your supply chain, because I think this is the biggest vector, and this is a really easy way for people to come in from outside your organization. You know, when they're trying to attack the network, they can knock on the front door, and if you've got a misconfigured firewall or you've got a CVSS 10 in one of your perimeter devices, they'll get in. You know, getting into the BIOS, it's not to say that certain organizations can't get into the BIOS of these servers, but again, it's easier to hit the supply chain, and we've obviously seen a lot of that. So your container image is going to have several things in it. It's going to have your app, you know, which I've kind of sort of highlighted in blue here. And then the container image is probably going to have a libc, and it's probably going to have a libSSL. Maybe you're building, you know, completely statically linked, you know, Rust or Go or something, but even Go links against libc more often than you like it to. You really have to tell it to stop. So you're likely to have these other things. CA certs is something that's often overlooked. It feels like every month, you know, a new root CA authority in the web PKI is found to be a dodgy front company or a nation state or somebody that we don't want to trust, and it gets yanked from that bundle. But nobody ever checks the online certificate revocation lists, right? So it really relies on how recently was your image built, how up to date was your CA certs package, have you had a version of that package where that thing's been yanked. So that's something that we can now do. Jetstack did a little tool where you can replace those at runtime, basically, right? And then you can block list in much more real time. But even, yeah, apart from CA certs, which is, I think, often overlooked, you're going to have, like, some binaries. What was I going to say? Yes. Right, okay, yes. Sorry, jet lag. But we have to trust something, right? I mean, I've talked about zero trust networks, but it's trusting nothing without verifying it. I don't know the Russian off the top of my head. But obviously there are some things you trust because there's some things you want to talk to, but you need to verify, take a load of steps to verify that that is what you want to trust and not trust anything else. And it's the same with the contents of your container image, with the code that you're going to run. We do want to pull in a bunch of packages. We want to use open source. This is what this whole conference is about. But we want to verify those things, and we don't want to trust anything else, you know, anything that we're not happy with, anything we've not looked at. So again, it's about getting this down to the smallest set of things possible, and then attesting the things that we have left to say that we do trust them. So, you know, your app, for example, is likely to have a bunch of dependencies. If this is, you know, this is Go, heaven forbid you link against like the Kubernetes API, you're just going to have like 1,000 dependent packages or something, right? And all of these other things like, you know, libSSL does as well, I'm sure, but that's maybe less of a concern. But your app's going to have a bunch of dependencies. So you can come along and you can sign the container image, you know, as the lead engineer, or your CI system can do it. But what does that mean? It just means that this big tarball of tarballs has passed across your desk, right? I mean, so it means that whoever runs it is running the one that was on your machine that you signed, but it doesn't often mean much more than that. You know, it tells you that this image isn't completely an completely unknown thing off the internet, but it's probably full of completely unknown things off the internet. So the normal approach to this is a document, right? An SBOM, a software bill of materials. Again, I didn't get a chance to do a full treatment of this, but I think this is really important. And you can think about it in the same way as we think about network zero trust. So you can get this software bill of materials that's going to tell you what's actually in your app, you know, all of the transitive dependencies, what's actually in your software. And this can help you reason about it, and this can be checked against CVE databases, and this can be given a policy for even, you know, open source licenses that you do and do not want to accept. It needs to be signed to be useful, otherwise you just can't trust its contents at all, but that's necessary, it's not sufficient. Again, just signing an SBOM, which is a huge JSON document that comes across your desk, isn't going to do much. So you need to think about it, you need to reason about what's in it, and actually your CI system should be signing it anyway. And I think one of the reasons we struggle to reason about what's in these containers, because I'm going to get onto the implementation, maybe some practical tips about how we solve this. One of the reasons it's difficult to reason about what's going on is because the way we build containers normally is we build them up in layers. We have a Docker file that builds them up in layers. You know, each one of these is a new run command that's going to say, you know, yum install, or it's going to copy something in or run an arbitrary piece of script. So each of these layers is imperative. That run command can have any piece of bash that, you know, does anything. Often people just call, you know, apt install or yum install, but those packages too can actually contain arbitrary script in their pre and post install hooks. You know, and these things are Turing complete, so decidability problem, no way of ever knowing what they do, no way of completely statically analyzing them. And you know, what I've tried to show here is we've got maybe the base image, and then we've got another layer. We've run a run command that's going to install, you know, an updated version of a package, or like a package that's going to mask some of those files. And then we've got another layer where we've copied our app in, you know, from build. So it gets quite dicey to reason about what's in there. So again, we want to take a sort of declarative approach that can be codified and that can be you know, verified against a policy at all times. So it's better to think about putting these images horizontally rather than vertically, right? Think about what packages you want to end up in the end image, not the steps you want to take to get there. And if we're going to take that approach, so we basically want to give a declarative list of packages, right? Is the spoiler alert. And if we're going to do that, it would be great to find a packaging format that doesn't allow those pre and post hook scripts, that doesn't allow any kind of arbitrary scripts up front, that would say, you know, do like a constraint satisfaction. So you give it a list of the packages you want, it runs CSAT over all of them, makes sure none of their files clash, works out exactly what the end image is going to be, and then just renders it out in one fell swoop, right? You could never end up in a broken state where the second package clashes with the first one. You can never have hook scripts doing arbitrary things that you don't understand. It turns out that package system actually already exists, and it's APK, which might surprise you, because maybe Alpine Linux is not your favorite thing. Actually, more likely, BusyBox is not your favorite thing, and you're blaming Alpine for that. But APK is actually really good and has a bunch of these desirable properties. So people have built some tools on top of that. So if you think about, yeah, how might I do this? How might I build a container image? You know, you could use a Docker file, very standard, very well understood, but it's got that kind of layering, masking problem that we've talked before. You could use Bazel if you hate yourself. You could use Nix if you're smarter than me. Nix is not a bad system, right? But it's quite niche, and it's got a massive learning curve. Then there's these tools, there's KO, which is for Golang, and Jib, which is for Java. They're kind of special purpose tools that take you, they're like a build system and a container build system. So they'll take your Go code or your Java code, and they'll get all the way to a container image. So like Java-C will emit you Java bytecode, which isn't very useful at all. The main Java command will wrap that up in a jar or a war or something for you. Jib will actually just wrap that in a container image, because container images are a packaging format at the end of the day. Right, containers at runtime and the isolation that they do is something different, but a container image is essentially a packaging format. So Jib does that for Java, KO does the same thing, takes Go source, gives you a container image. So it's all declarative, there's no imperative steps in there, there's no layers. So ChainGuard have come out with these tools at the bottom, which is a more generalized version of that, which is what I basically wanted to get to. So AppCo, APKO, is exactly the program that takes the declarative list of APK packages that you want and gives you a container image in one step. So you can say, okay, I want base, and I want libSSL, and I want up-to-date CA certs, and I want TZ-info, and I want, I know, lib something else to do Korean translation, who knows. I want all of these packages in my thing, and again, no imperative steps, no chance for scripts, nice package manager. So that'll give you one step to a finalized container image. That gives you all the packages for all the other stuff except for your app, right? How do you get your app in there? Because we're not allowing arbitrary file copies. We're not allowing arbitrary scripts. So Melange is another ChainGuard tool that is kind of like a generalized version of KO or Jib. You give it your build, whatever your software build is. You call your build tool, and it'll basically go and sweep up the output. You say, hey, I'm going to do a Rust build, and the output ends up in .target/release. So go scoop up the contents of that directory, and then that is a APK package. So you can then just go in, you can build your own thing locally, and you can then install it into your container image as an APK package alongside the one for libc and alongside the one for libSSL. What are those packages? Well, because I've talked about SBOMs, right? This is kind of why we're here. If we're actually talking about trusting the software supply chain, knowing what's in it, enforcing policy over it, all those packages that we install need to come with SBOMs, and we need to be able to trust them, right? And they need to be built in sort of best practice kind of ways. So that's what Wolfie is. Wolfie is basically a repo full of APKs. So if you think about Ubuntu uses Deb packages. It uses the apt program to install them, but they have their own repos. There's, repository.ubuntu.org or whatever it is. They have Ubuntu flavor Debians, and that is the Ubuntu operating system, basically, is an install of a bunch of Ubuntu packages. They happen to use Deb as their packaging format, but it's installation of a bunch of Ubuntu packages. Alpine is an installation of a bunch of APKs, but they're the Alpine APKs that the Alpine folks have built, right, to their to the way they want to build them. So Wolfie is another set of APKs, but it's built by the ChainGuard folks. They're more minimal, they're built in very secure, tested environments, and they all come with an SBOM. So it's kind of like an OS, except they don't give you a package for a kernel, and they don't give you a package for a bootloader, so you can never actually run it on a bare metal system, but it's everything else. So everything you'd ever need for a container image. And as I say, it uses APK deliberately. So that actually that's not so bad. I think that's kind of what I wanted to talk about. Again, that's the implementation. I think those three tools are really good. I've got a whole talk on them. There is a demo that works, I promise, but I don't have the energy for it. But yes, we have seen the problems with traditional, like perimeter-based network security, the principles of what this zero trust thing actually is, how we control that at runtime with our R5 pillars on the network, how we also need to, I'll say it, shift left, step back and look at the things that feed into that before we get there, how you might actually take that away and implement it, the regulations and standards that might help guide you and that you might automatically start ticking boxes of if you take this approach, which will make your regulator happy if you've got one. And then apply the same kind of model to supply chain security, trust nothing, and then how do we start testing things, and what does it mean to actually not trust nothing, but to trust the very minimal set of things and to trust them highly. So I hope that was useful and not too rambling. Thanks.
Thanks, Matt. So do we have any questions from the audience?
I'll do my best.
Yeah, I hope you're okay with that.
Yeah, it's fine.
I have a question which might be a bit specific. So do you know, it might also be a question that I should probably ask ChainGuard, but for Wolfie, do you know if they're maintaining old versions of packages? I think this may be something that as a security person is a bit of a niche sport, but I quite often want to find a specific old version of something that has a vulnerability because I want to prove it. But package managers typically don't keep those packages around. Do you know if they do that?
I don't off the top of my head. I'd imagine you could either get them from some mirror. They probably wouldn't want to make them available, so you couldn't make a mistake. You could probably get them out of the Internet Archive, I guess, or they build all their own stuff with Melange, so you could probably go write your own Melange file to take the GitHub repo of whatever it is and then build it yourself. It might not be byte for byte what was running if you wanted to prove a proof of exploit, but that would be that's a guess, to be honest. But yeah, no, it's a good point.
Cool, thanks.
That was either very clear or very not clear.
Any other questions about zero trust? Okay, well with that, let's have a giant round of applause for Matt for stepping in at the last minute. I hope we'll see you in here again tomorrow for more excellent talks in the platform engineering track. Now, I think there are drinks and entertainment, and I'm signing a book. And so hopefully we'll see you all out there and then back here again tomorrow. Thanks very much for being in the track today.